can separate the roles. So you can have like people running a fire and forget piece of software on the other side that is just every time looking at new offer for new loans, because that's what a VTXO is a loan, and they will say, yes, I will cosign. These people on the right that are running this, always on automated wallet server, they basically don't even care about rounds, they don't even care about storage or ARC in general. They just know that in 14 days, 1 month, they're getting back their principal, and they're getting also some fees. This, to me, sounds lending. So what's the business model of this? I think this is since the first bank popped out in Venice or Florence, I don't remember. I think in the end, it's a very simple business model lending in the end. No, like you go on a side, you try to borrow long term, a very low interest rate, right? And the other side, you are trying to reselling to short term in maybe medium interest rate, right? And that's what VTXO is. It's a very short term loan, and you know that in 14 days you're getting back your principal. And the other side, these, let's say, capitalists actually may want to do also custodial lending also on their side, because at that point, yes, you may be very early in Bitcoin, but you will finish your UTXO. So there should be somehow some lender of last resort. And I think maybe if you get crazy covenants, I have some ideas, but I think it's not the right moment. Maybe you can do some sort of lending under collateralized on chain, but at the same time, I think this lender of big resort, they will, do the one of the oldest job of the world, right? So they will just be a lender, and they will just trust, and they will just have a relationship with this always-on wallet server. Of course, you're saying, "Oh, wow, this is amazing! No, this is done. So what we're waiting for?" Now, of course, there are challenges. There is no marketing pitch here. This is just my my understanding and how I see Hark. And yeah, like the first, like lender, again, like in the same way, like routing nodes may have capital, may have Bitcoin, but they don't really know how to run server. So I think this is one of the challenges. So how we can make it really, fire and forget. You send to an address because you're rich of Bitcoin, but you don't really want to manage infrastructure. So that's definitely something that needs a lot more thinking and validation in the market. The other part, yesterday we were thinking, about what really is, like how an ARC work. But I think in general, like from the user perspective, like we know, for example, in Lightning, how much you're going to pay your fees is a percentage, right, which is charged by the node. In Bitcoin, it's not about the volume, not about the amount. It's about like how much the transaction weight. And I think in ARC is yet another way, and I think is a function of the idle capacity that is still there as lender of last resort, and also the cost of actually borrowing Bitcoin. And why I'm saying this is like, imagine there are just 10 Bitcoin as idle capacity in the ARC, and someone want to do 5 Bitcoin ARC payment. Well, that fee is basically consuming 50% of the idle capacity. That should cost really, really a lot. And the cost of the fee should disincentivize. So this is a different mechanics. So of course, for end user, they will need to understand that the cost of making an ARC payment will not depend on themselves, but will really depend on the liquidity, and is not under their control. But there is also, I think, an opportunity here, kind of, in this challenge, in the sense that now we have an interest rate. We can do lending, right, in the broader crypto space, but we borrow Tether and use Bitcoin as a collateral. So you actually, the interest rate there is the dollar interest rate. It's not the Bitcoin interest rate. So I think actually ARC is kind of could be a way to have price discovery, in the sense that it can like show what is the cost of borrowing Bitcoin. And I think this is a kind of opportunity it can be, because for everybody will say, why am in a future where we are hyper Bitcoinized and everybody's using Bitcoin every day, they will say, why am lending to you Bitcoin when I can make more money in providing to this ASP, for example. So that will create some sort of price discovery there, and ideally can be an oracle for the Bitcoin interest rate that nowadays doesn't exist. Nobody really is borrowing or lending Bitcoin. As I said, sure, reliability of these off-chain pools will not be super easy. Like, of course, economy of scale. If you're a single server that both coordinates and also provide UTXO, well, for sure that would be super easy to implement and easy, right? But at the same time, it's nice to have separation concern for many other reasons that are not only technical. So definitely this is something that should be looked upon. And here maybe I'm putting there, maybe Fediment is fixing this in the sense that why not? These lender don't form sort of cooperative. You know, if you were in crypto, they would say, oh, we're doing a DAO. But yeah, I think it's in the end, it's just a glorified multisig in the end, and I think Fediment can be a nice solution there to helping this lender to form an off-chain pool. And okay, this is the last point. It's very provocative. Maybe some ARC will say, hey, we are doing fractional reserve in the sense that, yeah, like we are not backing you one-on-one, we are backing 80%, which is much better than the dollar, right? We have 0% backing or the euro, whatever. But still, like there will be an agreement, and maybe my cost of transaction will be less. The caveat will be if I need to unilateral exit, if I have, I don't know, nominal value of 1 BTC, I will get 0.8 BTC, which is scary as a Bitcoiner, but you know, this is something that we should have as a challenge, and we should also put it there that can happen. And that ARC, that ASP will really charge less than the others. Of course, I'm a messenger, don't shoot me, but but this is definitely something that people can do, is open software, and user may decide if they value more one-on-one backing or maybe a little bit less, but we want to pay less fees. So this is to be seen. Okay, so show me the contracts, right? It's a Conant's conference. So we have on this GitHub, we have this repo called TypeScript. We are using Elements introspection of codes, mostly because we really wanted to not be, you know, to pick one Covenant proposal to how to build ARC. So I think having something that is production live, you can experiment, and is very flexible with introspection of code, so you can really push the boundaries. And in general, ARC, there is no spec, right? So I think that we're still really in an exploration phase. So yeah, you can definitely scan it. There is Miniscript definition and also the opcodes for the 4 paths, basically, that you know, the contracting primitives that are needed to implement ARC nowadays. But when ARC, like when we can try ARC, I think there are people already that reach out to me, and I did some ARC payments. You can scan in this QR code. There is a progressive web app live now on Liquid, so you can scan it, you download it, it's just a classic, you know, Bitcoin wallet, no? You have 12 words, and come to me, and after this, and I would really love to send you some VTXO and try it together. Thank you. Yep. Yes, sorry, say it again. Speak. Yep. Yeah. It's interesting because, yeah, again, this is my interpretation. So the thing is that what you're really doing when you have a VTXO with an expiration time, you're renting block space in practice. So you're really saying, I'm paying you a fee now for the liquidity that the ASP is locking for me. And to me, sounds alone, because in the end, he's getting the principal back after the 14 days, plus the fee. And in general, you're not owning a UTXO. Yes, you can own it with a unilateral exit, but unilateral exit is there just for, you know, for having trust in the ASP that the incentive are right to be live and not to screw you, right? Because in the end, like, you can always exit, but that should not be the case, like, ideally. Like, there should be always a long-running ASP. And of course, like, also the implementation matters. Like, what I'm trying to say with this, let's say, off-chain lightning pool is just looking that in the back, you don't have a single party, but you have multiple parties you need to coordinate there. They're doing actual coin join, you know, on-chain to have multiple UTXO, which is more, I'll say, you still use more block space, right? But I think overall, I think it's a good compromise to making sure you can have, you know, multiple liquidity providers coming together. I hope it did answer. Thank you.
getting fancy mics now. Hey, look, Mom made it. What does that do? All right. Hey, it works. Are we ready on the tech over here? Okay, no one move. This thing catches all your breath, doesn't it? It's like not breathe through my nose. Yeah, he put it up my nostril. Should it be over my nostril? I might just move it. Can you hear me now? Okay. All right, we're good. Thank you for coming to my Splice script talk. As you can see from the slides, it's very exciting. Made the right choice coming here. Let's go. So I'm Dusty Damon. I work on the Lightning protocol, primarily on splicing. That's me. No, demon's a different word. If you mix up the E and the A, it becomes demon. I use Damon to make it harder for people to spell, so they can't find me on Twitter. It works pretty well. But Damon's also a coding concept that actually core Lightning uses quite a lot of. Okay, so what is Splice script? Before I tell you the meat and potatoes, it's about building for the future. So Splice script like today isn't necessarily all that. Most of the benefits of Splice script come in the future. And mostly it's about doing block space optimized stuff and trying to build towards that world. And today, today fee rates are low. If you're trying to do the halving, of course, they were crazy high. But the way we get there is having more transactions be interactive. So today, people usually will make a Bitcoin transaction, and then they'll put it on chain, and that's sort of it. To optimize block space, we need to join more of these together. So the more stuff we can put in one transaction, the more efficient we are on the blockchain. So, and I wrote that there, yeah, so you can see it. The problem is that it's hard. Even Midjourney agrees that it's hard. Look how hard that photo looks. It's hard to do. It's possible. So like with splicing, splicing works now. All the base layer stuff is there, but trying to coordinate a splice, say, with someone else's splice and maybe with a channel open or something and some other on-chain activity, it gets really unwieldy fast for people to do. So you can do it, but you have to really want to. And with Splice script, doing all of that becomes super easy. That's the promise. And you can see Satoshi signed off on it. So that's good. Okay, so why does it matter? We covered some of this. One day transaction fees will be very high. We want to be ready for that. Origin transactions will make it better. And Splice script makes managing transactions that are merged really easy. The other thing that we can do is this Splice script will enable us to merge with external transactions generally more easily. So one thing you can join with is like a coin join, although those are apparently going away now. But that actually is more of an opportunity for this than a pitfall, because the reason coin joins are going away is because they're all centralized. And a lot of this gives us the building blocks to build decentralized coin joins, which is pretty exciting. Anyway, that's why it matters. You get all the benefits of splicing in an easy package. So I've been working for a long time on getting the nuts and bolts of splicing going, and now this is the usability layer to make it easy to do stuff. So we covered, it makes the doing splices now is a little unwieldy the bigger they get. People have to move PSPTs around, which a lot of people, it sounds simple in practice, but in order to do this correctly, you have to have PSPTs where you're modifying the inputs and outputs in real time. That's a little difficult. Using a Splice script, you can specify very clearly what it is you want to do, and then also once we have it in a unified place, we can use the Splice solver to do it in the optimal way possible. So there's a lot of ways you could do large, complicated merge splices and shoot yourself in the foot, particularly with maliciously added inputs and knowing which ones to sign or not sign. We're not going to go too much in detail about that. But the point is, using this infrastructure with the Splice script and the Splice solver behind it, you get all the guarantees you would hope for in doing one of these. And you can also, an important big one is that a lot of people today that are using Lightning to live off of, they'll have their on-chain funds, and when they want to move it to Lightning, it's a simple problem, and yet it's like everywhere. They'll move it onto their Lightning on-chain wallet, and then from there they'll open a channel into Lightning. So they end up doing 2 transactions, essentially doubling their transaction fees. And using some of the Splice script stuff makes that particular problem a lot easier to go directly from your funds and your cold storage directly into a Lightning channel. So that's kind of an obvious, easy win we can get from this. And that really boils down to making it easier for people to do that. All right. Feature things it could fix. We have people building their own non-centralized coin joins, which I think is ever present. I think Samurai announced today they're shutting down their coin join. Not Wasabi did. Samurai is obviously being prosecuted by the government. Centralized coin joins seem to be a target for governments generally. So if we can move to non-centralized coin joins, that's pretty exciting. Not that this does this by itself, but it's the building blocks that allow it to be possible. A future thing that I'm excited about related to this is moving from a transaction model to a transaction intention model, which we'll cover a little more later. Also, if you have any questions, if you're confused, please jump in with the question. I don't want anyone to be lost here. Yes. Yeah. Oh, great. Potentially, yes. Yes, absolutely. And there's also some benefits besides just coordination. Often with coin joins, you have this problem of what's called toxic change that happens. And with Lightning, it's pretty easy to just bundle that into an existing channel. So you end up with less change outputs generally, which helps in a lot of cases. Do you have a question? Oh, okay. Awesome. Is there a question over here? Yes. Which part? So that's in a future release. If you just keep waiting, it should come. 6 to 8 weeks, depending. So we're describing here as an intimate marriage of Lightning channels and on-chain transactions, which is what this solves generally, is combining the managing of Lightning channels with on-chain stuff. That's the idea. And it's built with extensibility in mind. So the specs can easily support new things that come along, taproot channels. We're going to add opening channels and other things to be added to it as more things come along. All right, so how does it fix it? Splice script is a standard syntax for clearly and concisely specifying all that stuff. So the goal is make one simplified language to do all that. And the goal is to make it easy and elegant such that people can, the simpler you make something to use, the more sophisticated people will use it, is the theory here. So if, say, doing a splice, just a simple, say, splice out, one of the simplest splices you could do, if that requires you to do half a dozen commands and manage a couple PSBTs, people will just do it less often. And with that, for that example, it's a one-liner with Splice script. Yes? You're absolutely right. You caught me, yeah. I called it Splice script, but it's growing to be so much more than just splicing that maybe it should be called the everything script, but that's a bad name, so I'm sticking with Splice script for now. Okay, and the more we get people using it, the less block space we'll be using, which will benefit those people with lower fees, but also benefits everyone out there using Bitcoin by lowering fees generally. And just from an engineering perspective, more efficiently using the block space. Okay, so we've been talking a lot about the pros and cons, what it's for. Let's get into what it looks like. So here are a couple examples. Don't have to understand them yet, but this is generally what it looks like. With the camera, can I move over here, or does it go off camera if I do that? Okay, cool. So basically, the main way it works is you have channel identifiers and then amounts. And so We have a splice out example, a splice in, some cross-channel splices. We'll go more into detail here, so you don't got to study it yet. But this gives you a sense of what it looks like. And the idea is you write out these scripts, and then you put them into into your Lightning node, and it just goes and does all of the stuff for you. It does all the work to make it happen. All right. We'll go through some examples one by one. First, any questions about all that so far? Yes? It's for the user, but also for people doing front ends. So if you're doing RTL, you'd probably want to use something like this. And there's a benefit there in the middle layer where if you want to get people building Lightning front ends like RTL to support splicing, if I make it easier for them to do it, I feel like they're more likely to do it, and they can focus on making a good UI and less on managing this complex stuff. There can only be one. No, there definitely is a JSON format for all of this. What the Splice script compiler does is it actually compiles this into the JSON format and then uses it. So, yeah, there's both ways. Okay, we're going to go through some examples, and please jump in with any questions. I'm hoping we can all understand Splice script after this. It should be simple. Fingers crossed. Okay, so here's an example of a splice out. Probably the simplest thing you can do. We have in the beginning of a channel identifier. Normally those are quite long, but we've shortened it. So in the Splice script, you can use the first chunk of a channel, and it'll auto-complete it to the full channel identifier, checking for collisions. And this will take out 10,000 sats from the channel, which will go by default into your on-chain wallet. Okay, who here knows what a splice out is? Okay, maybe I should describe that. We got a half wave, maybe half the room. That's exciting. By default, yes, and that can be changed. Okay, so just a quick primer on what splice out is that before splicing, you generally have your funds either stored in your on-chain or cold storage or hot wallet, something like that. You also have them stored in Lightning, and they're stored separately. And the way you traditionally move funds into Lightning or out is you have to open a channel or close one. And splicing enables you to keep a channel that exists and move funds in and out of it at will. And that's what the term splice means. So when we say splice out, what it means we're taking funds out of the Lightning channel and bringing them back to your standard on-chain wallet. All right, now who knows what splicing is now? Okay, I got most of you, or you're lying, and for my benefit, thank you. Okay, so so this is a splice out. In this example, we're taking 10,000 sats. If we can go through a splice in example, this puts 10,000 sats into a channel. This one won't actually work because you have to get the money from somewhere, right? If you could just invent sats, then Bitcoin would probably be broken. But the core idea is, since the number's on the left, it's pointing into the channel. It's kind of implying, hey, these sats are going into that channel. And the way we make that work is we got to get the funds from somewhere. There's a wallet operator. So if you just say wallet, take out 10,000 sats, and say put 10,000 sats into that channel, lo and behold, we got the funds from somewhere, and now we have a splice in. All right. Is anyone feeling particularly confused right now? All right, awesome. So this looks like it's 2 lines now, but it's still one script, and it looks pretty simple, but this actually won't work either because you have to pay for the on-chain fees. And so the way we specify on-chain fees is we pick where they're going to come from. So there's this other operator called the fee operator, and this just says, okay, when it builds the transactions, it'll determine what fee is required to publish it, and it will take out that much extra from the wallet to cover the fee. Another way to do it is to subtract the fee out. So we can move it over here and say, I just want to take 10,000 sats out of the wallet, but whatever you splice in, remove whatever the fee is from there. So in any on-chain transaction, the fee must come from somewhere, and this is how you control where it comes from and goes. So that's splicing in 10,000. And here's the same idea with splicing out, but we're being more explicit about it. So the original one we can go back to Splice out. This one was cheating a little bit, and we want to make it more explicit. We can add in, where to go here? Here. So here we're splicing 10,000 sats out of a channel, and then we're putting those 10,000 sats back into the wallet minus whatever the on-chain fee is. So the actual amount will be, 9,000 and something sats after the fee goes. Yes? It is included. So there's a special clause which is I'm going to cover a little later. But the way it works is if there's ever a let me get to that because I'll get to that later in the talk. But I think there's a better way that I can get to it. That'll make it a little clearer for everyone else. Okay, so that's splicing out to your on-chain wallet. A little more interesting is if you wanted to splice out to someone else's directly to someone's address. And I think this is actually kind of a powerful idea. The idea being you can store your funds in Lightning, and if you want to make an on-chain payments, you could build a script like this and then pay funds to an on-chain address from Lightning directly. This is actually one of Satoshi's addresses, so you could, this is a donation to Satoshi. But you might notice there's a problem with this script. Does anyone besides Christian know what that problem is? No fees. Yes, there's no fees. So this transaction won't go because there'll be 0 fees and it won't be processed. So we fix it by tacking on a fee. And again, we can subtract the fee or add it, but we probably promised Satoshi you'd pay him 10,000 sats. So we're going to withdraw 10,000 plus the on-chain fee so he gets his full amount. It's a little bit of trickery. There's what I call the general script funds. So the top line is taking 10,000 sats out of one channel. But you could take 5 from 2 channels. So you could have multiple lines taking funds out. Yeah. Yep. And then the miner fee is of the, say, 1,000 sats goes to the miners. The other way, which Christian was asking about to cover fees, is if you use percentages, then the fee will be automatically deducted out. So there's this concept of the general script funds, I call it. So on the top line, we're taking out a certain amount from that channel, putting it in the general script funds, and the bottom line takes all the general script funds. And if you don't specify a fee, the fee will automatically come out of there. So here we have 2 percentages. This bottom one is saying take all of the general script funds and move them into this channel over here. The top one is a little bit different. When the percentage is on the right side, what we're doing is say, of the available funds of that channel, take all of them. So this is not to be confused with the channel balance. This is how many sats you have available in that channel. In practice, you probably don't want to do this kind of script because you probably want to close the channel, not splice out all of the funds. You could try to do it, but you run into problems with reserve requirements, pending HTLCs. You'll never actually get all of your funds, just the available funds. So a more practical one would be something like this. Say I have a channel with a lot of funds in it, and I want to take out half of my sats in that channel and put them over here. This is a more like reasonable script. So this is a cross splice. Yes? In this format, it'll be 50%, and then the fee will come out. The bottom line here will be. Do I have a mouse? No, don't get a mouse. The bottom, it'll come out of this percentage over here. Well, the order can change. You can flip them, but you can think of it that way. Yes. Did you have to answer that? Exactly. Yeah. And the only nuance has been there could be multiple receiver lines. Actually, that goes into this really right here. So in this one, you're taking half the funds of this channel, putting it into 2 other channels, and the fee is taken out of the funds generally. So that's 50% of the funds minus the fee for both of them. Yes. Oh, I got to repeat the questions. Oh, we missed so many. They asked really good questions, and I don't remember what they were. Yes. 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 Yeah. Right, so the question is hard to repeat, but he's basically saying that it's a little confusing. Because here on this example, we're taking 50% of the funds out of the channel, 100% of that 50% goes down there, and here we're taking 50% of the channel, then 50% of that goes into that, 50% of that. So the way I would think of it is try to think of it as we're taking half those channel funds, and they just go into this magical general script funds area, and then totally separately, the bottom two lines are taking half of that. Well, is the top line special in the script? I mean, there'll be some more examples that maybe make that more clear. Yes. Yes, I think actually that translates. Oh, the question is it good to think of these as forming inputs and outputs to a transaction? So the top line would be an input to a transaction, bottom two lines would be outputs. And yes, that's absolutely almost precisely how you can think of it, yeah. There's a couple of corner cases, but that's basically what happens. Well, the question is go over all the corner cases. Well, we got some more coming. There's a unnecessary complex script at the end. We can go through that one. I'm glad you're excited about it. That's it, yeah. It is pretty straightforward. I'm glad that you can pick it up simply. He's just saying that it's too simple, and he wants to do more complex. Okay, so now this is the same example as the last one, but instead of dividing it over 2 channels, we're doing it over 3. And you might notice these numbers don't actually add up to 100%. In this case, we'd be losing 1% of the funds. So we have a special way to make that easier, and you just put a little star, and that says divide all these funds up among everything else using a star. Yes? If it messes up, does it yell at you, go to the minors? Well, first it tells you girlfriend, if you have one. No, generally it goes through a whole compilation phase, and if there's any obvious errors, it'll stop you there. And there is it is recommended that you do a dry run of the script. So this is where you put it in, it will process the script, and then tells you what it thinks that will do. And you should always do that first and verify that it's doing what you expect. Yes? It would go to the mining fee in this case, yeah. And this doesn't lose that. Yes? Oh, fractions are coming, but only for your node, and we're not going to allow you to use percentages. No, not currently. I mean, we could talk about that, adding it. It's extensible. I don't know who'd want that. Maybe you want that, so maybe other people do too. Yeah, PR welcome, yeah. Yeah, you can always be explicit that way. Yeah, he said you could always be explicit by actual amounts. You could multiply your fraction by the amount of sats yourself, and then do it that way. You can also do anyway. Yeah, you can also do like decimals on the percentage, a little more precise. But and then you can also add a fourth one. So this is taking the funds, dividing it out, splicing it into 4 channels, right? Point being is the asterisk allows you to do a bunch of those. The other thing we've added to the Splice script is new format specifiers. So we have the standard ones on the bottom there, SAT, BTC. But we also added M and K, which is kind of how you see it more in common written usage on like Twitter and stuff. So you can do thousands of sats or millions of sats, and that ends up. You've seen me use the K so far, but M and other stuff exists. I'm excited about those. And I think they make the scripts look prettier. Like if you go back to one of these, like that looks a lot prettier to me than actually typing out like, 10,000 in numbers. And I like things being pretty. And hopefully people will use it more if it's pretty. Let's pretend yes. So what's I don't actually understand the question. Is it following a Bolt 11 encoding? It's not using Bolt 11 for anything. All of these, look at that to the. All of these numbers just get parsed. He's asking if it's like a Bolt 11 encoding. These just get parsed once, and they're stored as sats internally. So they're only ever parsed, turn it into sats, and internally it's just sats. But this is like a convenience for writing out stuff. Oh, really? Ah, oh, interesting. Oh, interesting. So we're not doing that. Yeah, Perl request. That's a tongue twister. PR request encouraged, but it'll probably be ignored. No. We also have this thing of like people like to refer to channels by their peer identifiers, which is a challenge as a Lightning developer. But there's a syntax for what are called channel queries, and here we have a peer at this address 03 something, or that's their public key, and we're indexing which channel we have with this guy. So say we got 3 channels with this guy. This allows us to put 10,000 sats on all 3 channels, and the colon puts an index. So if you look closely, you'll see a colon there and a 0. That's the first channel with that guy, and then the second, third. So this is just saying for each peer, for this peer, we're going to get those 3 channels, put 10K sats in. Anyone confused by that? Hopefully it's colons can be array lookups. Great, awesome. Just now to confuse you a little more, instead of doing numbers, we can do a question mark, which just says the next unused channel for that peer. So these sort of get consumed. So this and this end up being the same thing, but the question mark makes it a little easier to specify. And then we can condense this script even more using another fancy operator with the asterisks. And this says to go to that peer and get every single channel that peer has. So all 3 of these are exactly the same script, but this one's a little shorter, which is nice. Okay, any questions? Yes? If you don't have enough sats, the script will fail and tell you, should tell you how many sats you're short. It'll fail, yeah. The thing is, you don't actually know how many sats you have in a channel until you freeze the channel. It's a moving target, right? So at any point that could change. HTLC can go through. So what the Splice solver does is it first freezes all the channels with the SDFU command, and then gets the actual balance available in each one, and then checks it then. And at that point, if you don't have enough, it'll then abort the whole thing. Yes? So the question is, does each Splice script refer to a single Bitcoin transaction? Yes. And the idea is every one of these would be a single Bitcoin transaction. Exactly. So if you're doing splice from 3 channels to 3 channels, you're doing it all in one batch. And that's the idea. Like here we're doing 5 splices in this one script, but it's all bundled into one transaction. And hopefully that kind of shows some of the elegance of this. It gets really easy to bundle a whole bunch of stuff into one transaction. It's sort of like, it's easier to do it that way than not almost, which is sort of the goal to encourage people to do it. Any more questions on that? Yes? Yeah, the question is the asterisk mean all channels related to this peer? Absolutely, yeah. It'll pull 10K from each one. So these 2 are identical. You know, I don't know if it's the best example you'd want to do. It's more just illustrating the thing. The next example is one you might more practically want to do. So let's just jump over to there. I might answer your question. Okay, so here's an example that's kind of fun, is we're using 2 asterisks now. And if you look at these, what they're doing is they're saying, so we already know the asterisk after the colon means every channel for that peer. On the left side, it means every one of my peers. So with this 2-liner, we've taken 100,000 sats from our wallet, and we've spliced it into every single channel we have. So if you have like a dozen channels, this will splice it over all the channels that you possibly have, which is probably a more interesting use case than just one node. Question is, why would you do this? Well, I mean, how else are we going to get a girlfriend unless we do cool stuff like this? You know, like it gives you a tool that you can use for silliness or for serious stuff. You can always just specify the channel identifier. That's the simplest way. But doing it through peers is possible too. So on the top line, he's asking about, I'm just going to explain it because on the top line, we have the wallet on the left of the air. It's pointing out to the right. We're withdrawing 100,000 sats from the wallet. And on the next line, we're saying 100% of whatever there is, which is going to be 100K minus the fee. We're going to put all of that into this funky star colon star. Yes, if you have 5 channels, it evenly distributes to those 5 channels. Exactly. Yeah. You could also go the other way if you wanted to splice out of all of your channels. So in this example, we've moved it around. So now the fancy star colon star is on the left, and we're taking out half the capacity from every channel on our node, and then we're depositing it into the wallet. Okay, any questions on that? Because we're going to start getting more complex here. So I want to make sure everyone's feeling comfortable. Yes? Yes. The question is, are we talking about our side of the channel? And absolutely. These are just the funds on your side. The funds on the other side aren't your funds. You don't really have access to them. But we will talk about the other side a little bit in the next slide. Fun enough. Any more questions before we get to the complex stuff? Yes. The colon separator, whenever there's a colon, the left side is a node identifier, and the right side is a channel index. So when you do star star, you're saying all nodes, all channels. It's just a general like wildcard. Give me everything. Okay, now we're going to the complex. Any more questions before the complex stuff? I'll hide the complex slide. For every line, one identifier is a channel identifier, and the other one is an amount. Well, we have that example back here. This is single node, all channels on that node. So the identifier of the channels on the left, 03 whatever, is a node identifier. And then with colon, it means all the channels for that node. But when you replace the 03 with an asterisk, okay, all right. The question was, please ignore me. No, Toodle's great. Okay, so any other questions? All right, we're going to complex stuff. All right, here is a really fun example, I think, is a balanced splice in. So we have a channel that already exists. This channel identifier is 8338 something. And we want to put 10 million sats into that channel, but we want our peer to also put in 10 million sats. So hopefully the first part of this should be recognizable. If you ignore this part, hopefully you should understand the rest, right? So we're taking 10 million sats and we're putting all of it into that channel. But this new part is a lease request. So we're requesting that our channel peer put in 10 million sats and we'll pay to lease their liquidity. So the net result of this should be both you and your peer putting in 10 million sats into the channel. Yes, this only works for peers that are running liquidity ads. Yeah, this is kind of future-y stuff, you know. But you should never actually do this because your peer might charge any percentage on that, right? So you want to add a limit on how much you're willing to pay. So we do that with more symbols. And here we have at 1%. And what this means is you will lease 10 million sats as long as it costs you 1% fee or less. You'll take the smaller amount of that. If it's over 1%, then you'll abort the splice. Any questions on this? Yes? The question is, does your peer know what your max is? And no, you keep that super secret. Yeah. That's why you don't live stream when you're working on your Lightning node. Then they'll know. Yes? But no questions. Okay. Yes? The question is 1% for the lease fee? Yes. It's your max lease fee that you're willing to pay. And it's a percentage of the 10 million you're asking them to add in. Any more questions? Okay. You can also do this weird thing where you don't put in anything. And this is actually a lease-only request. So we're putting in splicing in 0 sats, and we're like, yo, channel peer, you put in money. I don't want to put any money in. And this is how you would make a lease request for them to put in 10 million sats. But again, there's a problem with this script. There's a reason you shouldn't do it. Can anyone know what that is? Limit the fees, yes. Reardon code is right. We've got to limit the fees. If you want to be reckless, if you don't care. Yes. Not yet. Coming soon, TM. 2 weeks. 2 weeks. Okay, so that's lease-only requests. This one also doesn't work for another reason. Can anyone guess what that is? There's no but close, but not it. It doesn't specify a peer. Well, the channel identifier will have a peer on it. There's no on-chain fee. Reardon code gets it again. There's actually no fee here, right? And as you are requesting a lease, you have to pay the on-chain fee. So there's this crazy trick we can do where we splice out 0 sats plus whatever the fee is. And what's cool about this is we end up adding no inputs or outputs to the transaction. This will take just the old channel funding, put it into the new channel funding. The fee will come out of our balance, and it's up to our peer to add their funds however they do. So this is, I think, a particularly elegant way to really save on inputs and outputs. It does look wonky, though, but it's cool on the inside. All right, any questions on that? Great. All right, another example. This is not actually implemented yet, but it's coming. This is if you wanted to, say, splice out 500,000 sats and then open a new channel with a peer. This is how this looks like. So this would probably be a pretty common thing where and today a lot of these node operators store a lot of funds on chain, just waiting for an opportunity to open a channel. And with splicing, we had a great opportunity to say, no, store it in a Lightning channel. And then when you want to open a channel, just splice out into the channel open directly. And this allows you to keep your funds not sitting around being wasted. So this example, we have a channel already. We take out 500,000 sats, and we dump it all into a new channel with the peer that starts with 0346. Make sense? I'm going to take silence as a yes. Got a head nod. Got one head nod. I'll take it. All right, and now combining that all together, making it complex. Now we're splicing out to a new balanced channel. So we're doing the same thing. We're taking out the fee. We're also leasing 500,000 sats at 1% from the peer. Take a moment to read it. Do you guys? So who here can read this and understand what it says? Oh, I'm not gonna. Oh, I got some half hands. We got one solid hand. All right, why don't I slow down and go through it a little bit? Okay, so here we have a channel that we already have on our node. And we're going to take out, because of this arrow, 500,000 sats. And additionally, we're going to also extract whatever the on-chain fee is required. So this top line should be pretty recognizable. This is a splice out. I got to be in range of the mic here. This is a splice out of 500,000 sats plus the fee. And we leave 500,000 sats that are usable elsewhere on the script. So they're just kind of floating around there. Down here, when we say 100%, we're taking those 500,000 sats that are floating around and saying, take all of them, and put them into this next line, whatever that line does. And it's easier to skip over, ignore this section for now. Follow the arrow. We're saying, okay, we have this peer here, and we want to open a channel with them. So we combine the splice set of 500,000 sats plus the 100% going to this open channel command. Hopefully that's clear that we're splicing out 500,000 and opening a channel in one transaction. That's the goal of this, right? Which I think we actually covered over here. It was a little simpler. Yeah, that's this. Yes. Yep. He's just saying this is cool, I think. He said, oh, it looks like the fanciest script he's ever seen. So we've added this section to this slide, and this is our lease operator. And the idea is left of the pipe is the funds we're adding. Right of the pipe is the funds we want the other side to add. So we're requesting they add 500,000 sats, and we want the fee they charge us to be less than 1% for doing that. So this is how we open a new channel. For it'd be 1 million sats, half on each side. A little less because of you'll pay that 1% fee. It'll go over there. It will be 1 million sats, but you'll have a little bit less than 0.5, and they'll have a little bit more for the fee you paid. Okay. Any questions on this? Oh, this actually is. So the question is the fee in the channel. There's two fees. One is the on-chain fee, which is going to miners. Just through your channel. Yeah. Yeah. So what happens is, just to explain what he got, is so we're putting in 500,000 sats here, and then 1% of that gets immediately pushed over to the channel peer to pay them for giving us their liquidity. Okay, any questions? Any more questions on that? Okay, who gets this script now? Oh, more hands. Yes. Yes, that's great. Okay, this one should be a lot simpler, but it's a really cool one, I think. This is an externally funded channel. So this is just opening up a channel for who knows how much with this channel peer. And the idea is when you use this, you bring your own PSBT. It's like a BYOP, I guess. And you'd bring a PSBT with some funds in it from somewhere. And then this script will then merge it with the channel open. And then you guys both sign the resulting PSBT. So this is a simpler script, but I think quite powerful for that problem we were talking about earlier. There's a lot of people that are moving their funds to their Lightning on-chain wallet and then from there into a channel. And this makes it happen in one hop, which is better for everyone. Oh, he's saying I'm pragmatically helping with dual-funded channels. Yes, absolutely. Once they implement it, yeah. So this is, okay, now we have that example down. Now we're going to add a liquidity lease to it, just because we're going through the complex stuff, we're getting used to it. Same thing, but we just added a liquidity lease for 500,000 sats from our channel peer. So now we're getting a balanced channel funded from some external source, right? So the way this might work is you have like your cold storage device on using a desktop or some kind of software, wallet software. You would get funds out of there, build a transaction with that, PSBT it over to here. It would send the result back to you, sign it with your hardware device, and then send it back. It's 2 hops. And then you have your balanced funded channel. All right. Any questions about any of that? Okay. Final chance. All right. So all of this means that we can merge all of this stuff together, leading to a utopia where we get everything done with less transactions. You know, one day we'll have like 2 transactions per block or something. It won't be that many, but... All right. Okay. So we got one more example that I want you to prepare yourself for. You know, if you don't feel technical, maybe shield your eyes. You know, look away. We're going to go through one big example, and this is important because the goal of this is to be able to do big lots of stuff that will get automatically merged into a transaction. That is the ultimate goal. So the easier we make this script stuff, the more likely people, I believe, are to merge their stuff into one. All right, we got this big example. Do we have a volunteer that wants to tell me what the first line does? He said the first line, you get 100 million Bitcoin. It's close. 100 million sats, yes. Okay, and where do those funds go? Well, it's kind of a trick question. Yeah, it's the general script funds. They're floating in the script. I call them the general script funds, GSF. You know? The Splice budget. Yes, I like that. All right, who wants to answer what the second line does? Yes. Perfect. Take half of whatever's in that next line channel is what he said? Yep. Yes, and add it all to the general fund. Boom. So GSF has 100 million plus whatever half of that channel capacity was. All right, who wants to answer the third line? This is a complex one. Yes. I love it. Yes, I said, well, killed it. So he said, I'm repeating that's going to be hard. Okay. Said you're going to put 10 million sats into this channel and also request 10 million sats from your channel peer with a max fee of 1% going into the channel identified on the right, 09 AD. I love it. All right, who wants to answer the fourth line? Yes. Same thing, but open a new channel. Yep. Yep, you can almost copy paste it. Okay, and then we got the fourth line. Anyone, a new person want to try to answer this one? Yes. Peer ID. Has to be a peer ID for open channel. That's a great question. Question is that fourth line a peer ID or a channel ID? That's a peer ID because you don't have a channel with them yet. All right, who wants to answer the fifth line? Yes. Yes, you said take 3 million from the general funds, put them in that specific channel. Love it, killing it. Anyone else want to guess the next line? Yes. Donate 1 million Satoshis to Satoshi, which is correct because this is a Bitcoin address, but it happens to be one of Satoshi's addresses. So this puts 1 million sats in that. It's a tongue twister. All right, who wants to guess the next line? Oh, yes. And it's good because it's kind of a trick question because he's saying whatever's left in the Splice divided up by these two channels. Which is exactly right. So the stars mean whatever's left, put half of it in this channel, half of it in that channel. So great. We got it. Yes. Ordering only matters for the channel queries. The star ordering doesn't matter. No. Yes, exactly. Oh, so the question was, does ordering of stars matter? They don't matter. And then you're saying you execute everything and then the stars last, which is correct. Yes. Oh, that is a great trick question in the script. Where are the fees? He's asking, do the fees get paid by Satoshi? Like, poor Satoshi's getting less sats. Do you want to answer, Tidwell? Tidwell says, I think they get destructed from the stars. That's exactly right. So all the funds go in the general script funds, and whenever you have a star or a percentage, the fees get taken before those get calculated. Yes. Yes. I plead the fifth. I refuse to answer. No, this is not a coin join. Something like a coin join. Yes. No. No. And I can't think of a use case. Oh, the question is, that's a great question, really. If you open a channel with that peer ID like we do on line 4 here, 0346, can you then reference that channel again elsewhere in the script? And the answer is you can't. And I'm trying to think, I don't think there'd be a use case for that, because if you're opening a channel, you wouldn't then want to splice into it in the same transaction. It would break a lot of things, but I don't think there's any real value in it, right? Because you should just change the funding amount for whatever you were going to splice it for. Yeah. Yeah. Exactly. Yeah, so what he's saying is they're all netted. If you reference a channel 3 times, each pulling out 10K sats, it'll just merge it into one 30K sat withdrawal. Yeah, and it should be merged. I don't know if the code does it today, but it should, or at least it should error, one of the two. He's saying if you reference the channel twice for 2 different splices in a splice script, they should get merged. Similarly, like if you reference the wallet multiple times, that should get merged, right? Like if you are wallet funding into the general funds and wallet funding out, it just subtracts the two. Like whatever, either more funds come in or more come out, and it just does that one. Yes. It's a great question. So she's asking if there's an error, like say you don't have enough funds, will it execute to that line and then tell you, or will it abort the entire thing? And it will abort the entire thing and tell you why it aborted it. Yes. The bottom 2 lines here. Yeah, exactly. They're just like, they end up being a percentage that takes whatever is left over. We don't even know what that amount is, but put it in these channels. Yes. This is a great question. Should you do a dry run? And absolutely, there's a dry run flag that you should always pass in when you build these scripts, and it gives you this description of what it thinks you should do, which actually will come up in 2 slides, although we're short on time. Correct. No, that'd be more of a wet run. Yeah. All right. Any more questions on this? Okay, I want to show you. Okay, I want to show you an unnecessarily complex example. We're not going to go through it, but this is one to test you. It's actually straight from the unit test, purposely trying to do obscure, broken-looking things that are technically valid. But you can see on line 4, it's taking money from a wallet. It's doing all kinds of channel queries down here. It's using full channel identifiers here, or short ones over there, and it's just purposely trying to confuse you. Oh yeah, so we didn't go over semicolon. That's a great catch. You can use semicolons or new lines. They do the same thing. And if you're trying to use it on a command line, semicolons are a little easier to use. Yes. Question mark is it's for the channel index on a node. It's the next unused channel, right? So if I have three channels with one peer, the question mark is just give me whatever the next one is that I haven't already referenced in the script. If you just say the node, this was your question on the PR, wasn't it? I remember now. You were saying you wanted to have just node identifier with nothing else, have it find the one channel, which that's a good to do. Anyway, I feel like I'm probably over time, so I'm going to speed up a little bit. Here is a dry run, what you get if you dry run that script, to give you a sense of it. And what the compiler does is tells you what it thinks should happen. So you should run a dry run whenever you do one of these. And so it's just saying, in bulk, it's trying to withdraw. You can see the wallet withdrawal. That's probably an easy one. On line 3.5 there is wallet withdrawal 1 million. You can see right there, wallet withdrawal 1,000 sats. And all of this should match what you expect. So when you build these things, you definitely run a dry run first to make sure it looks correct. And I will speed up. We can skip over. Okay, I should touch this. There's some future work after the Splice script stuff where I want to do what I'm calling transaction intention language, TIL for short. And this is going to be a merging of Splice script plus delayed actions. So instead of saying do it right now, we're going to say I want this thing done in the next 3 months, ideally at this fee rate, at most at this fee rate kind of thing. And this will go into a time solver that can basically, the reason you need this is in order to merge transactions, if everybody's doing them what they want to do right away, there's less opportunities to merge. But a lot of things can be done over time. So if I can do it any time in the next 3 months, I can wait for somebody else who's doing one, add it to it whenever they come through, say in a month. And so this is like a future design goal language to coordinate that. And it's not a coin join. It's just a thing that helps you do things, maybe like coin joins. But anyways, ignore that slide. And you know, the goal is to build. Haven't started it yet, but the goal hypothetically of the till is to make it so we can describe all transactions that happen through intentions, moving away from building transactions to describing transaction intentions, so they can go into solvers that may be across multiple nodes and places, and they can be merged into large transactions that are harder to track. And there's me. Thank you. Thanks. Did you have one more question? It's a plugin in CLN, a default plugin. It comes by default with CLN. A PR Bitcoin Core? Yeah, absolutely. No. Yes. Oh, the question is, did I first consider using Miniscript for this? And absolutely, it just wasn't as big enough. You know, MacroScript maybe could pull it off, but you know. Any more questions? All right, thank you so much.
Test, test, test. Great. Oh, it split my screen. Gosh darn it. I don't know how to use my computer. I got it. I just gotta hit the mirror button. There we go. There we go. All right. So I just roll right in. All right. All right. Okay. So I also have a lot of slides. I added like 6 slides because of Rusty Russell, so blame him when this also goes a bit long. But it's good. It's worth it. So I'm going to blaze through some of my slides. Forgive me when I skip some important things. And then we're going to go a little slower on some of the new slides that are based on what Rusty was talking about with the script restoration project. So, but the general topic here is quirky covenants. We're going to use and abuse some opcodes to make cool things. And who am I? For those who don't know, I'm that guy on the Hellbird site. I work at Swan right now on self-custody things. Swan is awesome. Use Swan Vault. That's my pitch. So here's the things we're going to talk about. When we're talking about covenants and scripts and things we want to build, a lot of us want to get better vaults. And there's been a lot of talk in the last year or so about some of these opcodes like CTV or APO, which is a SIG hash flag. Lightning symmetry is super useful. And then last but not least, how can you make opvault do things it wasn't supposed to do? So if one thing, I talk about LEnhance in this, there's a proposal I have to put those 3 opcodes together. I think it's a good way that we could increase Bitcoin script flexibility. So yes, when I say LEnhance, that's the 3 things I mean. Other terminology, for those who might have missed it yesterday, Rusty Russell talked yesterday about restored script. And this is the description of that in short words. So with restored script, you bring back everything that was in the original script, plus a few new things to support Bitcoin as it is today, and you make it safe. So that's the restored script in a nutshell. Okay, let's get right into it. What are vaults? What's the problems with the vaults the way they are right now? So vaults have been around for a long time. Originally, they were done with pre-signed transactions. You put some Bitcoin, you make a key, you put some Bitcoin in that key, you pre-sign some ways to get that Bitcoin out that can only be spent maybe after some delay, and then you throw away the key you used to pre-sign that. Okay, so now you've got a thing in a vault. It's very safe because you don't have the key anymore. But for those who don't know, you can't actually delete keys. That's not a thing that you can prove has ever been done. And so you deleted the key, but maybe your stupid computer left it in some semi-volatile storage and someone could get it later when they steal your computer, right? So it's likely you can actually use pre-signed vaults, but kind of not. Okay, well also we have, if we were to just put CTV into Bitcoin, you can make simple CTV vaults. This is something that James O.B. originally wrote, and these are cool, but they also have problems. You have to have a separate hash for each UTXO, or for each size of UTXO you want to deposit into your CTV vault. And that's kind of a weird, tricky thing where if you make a CTV vault and then you deposit the wrong size UTXO, it could be stuck there literally forever. It's just burnt Bitcoin. So that's kind of a problem. And with both of these, there's some data that you have to hold on to be able to spend the things. You have to have the transaction pre-images for CTV. That's maybe easy. Those could be something you could regenerate. The pre-signatures, if you lose those pre-signatures, money gone. All right, can we make better vaults? Here's where I'm gonna start blazing through some of the stuff here, because I think you can make better vaults with lenhance, with checksig from stack, and taproot and check template verify. And this is how it would look. There's a couple different ways you could structure this. There's two different ways you could make the vault output. One would be using, I'm using descriptors on this one. I don't use them later. Sorry about that. But the short version of what this slide shows is that you can make a kind of vault using two different variants of vaults, using checksig from stack that have, I think, usable properties for people that could actually use vaults. Because simple CTV vaults, they're not particularly usable. Pre-signed vaults, definitely not very usable. But lenhance vaults, the key thing here is that with a lenhance vault, if you do it in the top way here, you can deposit funds to it. Then let's say you have your safety key, like, I don't know, you're split between two countries. You can go visit one of those keys. You can pre-sign some ways to get the funds out of that. And then when you visit the other key, you can all co-sign, and now you have an active vault. In the meantime, before you visit your keys, the funds are just locked to those keys, which is kind of fine. They're in your super cold wallet. But if you kind of periodically visit your keys, which is often how I think people in practice use cold multisigs, they've got the keys distributed, say, like, you know, one is in a safe in their house and one is in a safe at their best friend's house that they visit twice a year. So twice a year, you have an opportunity to update your vault for new amounts, for new UTXOs, whatever you need to do, using this kind of a post-signed vault system. Also, with this, once you've signed for a UTXO of a given amount, you can deposit more UTXOs of that amount and withdraw them. So that's kind of the idea behind this design of vaults. I think I talked about a lot of what I said on here. Yeah, so I'm going to skip most of this slide. But here's the summary. Depending on the user's needs, these can provide a permanent situation, permanent reactive security, where you have a deleted withdrawal key that's kind of like the pre-signed vaults, but with better properties. Or they can have that you can revisit your vaults, revisit your cold keys and update your vault repeatedly. And I think that those two are usable for different people, depending on their needs in a vault. You know, like an institution might use one, and an individual might use another. So I thought, since lenhance is now active on MutinyNet, this could be fun to build in a hackathon. I have at least the basic scripts here in this presentation. Okay, I added this recently, so forgive bugs. This is, I wanted to see how close we could get to emulating opvault with Rusty Russell's restored script that he was talking about, because I really like restored script. So I really want to see, you know, what's the limitations of this. And I immediately found out, and then talking with Salvatoshi, found kind of there's some limitations in doing vaults with this. But what can we do? Well, this is what it takes. One thing that is annoying about this, at least if you're me and you've been fighting with cats for a long time, is that it takes several cats. And, you know, that hurts my soul. But what is very nice about it is that it's a bit of a big script. We use several of the new transaction field selectors that you would use with optx hash or optransaction, optx. And by using those, we're able to make very clear assertions about what's happening. So this script may be a little bit intimidating at first, but if we look at line 2, we're getting the single output, which is just the transaction output script pub key and amount. And we're verifying that the script we built on the previous line, which has the input amount in it, matches that. And I think that is basically makes explicit some of the automatic amount stuff that opvault does under the hood. I should have put a slide in about what opvault does under the hood before we did this. So, oh, that's right, opvault is coming up next. So like, yeah, watch these back in reverse, and you'll be better prepared for this talk. No, yeah, so opvault automatically does amount computations to make sure that all the value travels from the inputs to the outputs within the vault or back to the vault itself. And so this does kind of the same thing where I grab the amount from the first input and I make sure that it goes to the output. The downside of this kind of structure here is that it can't combine inputs the same way that opvault can. But I think that's okay. If you're going to use a vault, you're going to put big UTXOs into your vault. And so maybe in a real case, you're going to have like 1.1 inputs per unvault. Yeah, Christian. Absolutely. If we go that far. Yeah. Yeah. Christian points out that if we go all the way with restored script, as Rusty mentioned, we could also add iteration over inputs. And if we did that, then we could do the full vault with restored script. I personally expect that we won't. We'll stick to restoring more than expanding when we do this restored script project. And in that case, we'll be limited in this particular way. But again, I think, raise your hand if you disagree, that vaults are going to be used with fairly large UTXOs. So the more common case is you're going to want to put part of the UTXO back, not that you're going to need to move value from several UTXOs out. Okay, so that's... Oh, right, yeah, totally. So the steel transaction costs more in fees, yeah, absolutely. This is the simple script. This is the recovery script for a restored script vault. So this is what you use when you're sending all the value from some UTXO to your safety key, whatever your safety key or your recovery SBK in this case might be. And how exactly a user might structure that, you could actually put kind of a safety key both as your taproot internal key and also the place this goes in that event. Again, people can use this in various ways. That's one of the suggestions that James has on his opvault BIP. Here's the locking script for the vault itself. This one gets a bit uglier. There's a god-awful lot of cats up on that slide. The thing that I really want to point out about this, basically there's two parts to this script. One is building a tap tree in script using restored script. As you might expect, that's somewhat similar to building a tap tree in cat script, as Rindal does. It's basically the same structure, except we don't have to do quite as many cats. There's still, I didn't actually count them, there's like still 10 cats in this script. Rindal uses about 20 cats per introspection. We have 10 cats here, so there's a lot of cats floating around this room. But the point is we build up a new Merkle root for a tap tree, and then we verify basically the same thing, that all of the value coming in from the inputs goes to that tap tree that we built. So the bottom part here is very similar to the recovery script, which is why I put that one first. And again, and the result here is that when you run this script, it creates an output who can be spent either to the recovery script we just saw, or using something delayed by that 18 CSV up at the top. And I used Rusty's invention, opsegment, in this, because that way I can take a full script straight from the spender and not worry about an op success being thrown in there and ruining my vault. So this is why, a concrete use case for why Rusty suggests adding op segment, because we have op success now. When you didn't have op success in original script, you didn't need op segment, but now we have tap script with op success. We need op segment so that we can simplify these things. Whereas with opvault has to avoid that. You have to pre-code the script fragment and just take arguments for it from the stack. Because otherwise you would risk having just pushes, pure pushes rather. Because otherwise you could risk an op success being thrown in there. Op segment, the very top line of the script itself. 18 CSV op segment. Yeah, so what op segment is doing there is that in checking for op successes, we evaluate the script in segments so that I can say this precondition must be met. The 18 CSV must be met before you check anything else. And then if it can fail on the 18 CSV, and if it fails there, the script never executes. The rest never executes. If you get past the 18 CSV, then you check the rest, which could have op successes. And it could be that anyone can spend at that point. But the vault condition, which is that you must wait 18 blocks, 18 blocks still holds. And that's the important thing, is that you must wait 18 blocks before you spend this, because that gives me a chance as the vault holder, someone stealing it to an op success script. Why are they doing that? Because they're a miner, I don't know. But they're doing that, they're stealing it to an op success script. I can still recover it to my safety path. The segment protects me from it just being a full op success. Yeah, it did well. All the way to confirmed. Right, because you confirm an output to a script with 18 CSV op segment as the spend script. Yeah, so for 18 blocks, I have a chance to send it to my recovery. And again, that's very similar to what opvault does, so watch the next talk, and then come back for this one. Okay, so this is pretty cool. The downside of this is it is a bit bigger than using opvault. I kind of guesstimated and hand waved that I think it's about 8 VB larger for opvault when you're doing withdrawal, and 16 VB more total when you're doing a recovery. So this is more expensive than opvault, but you can build it in just restored script without a specific vaulting opcode. So I thought that was cool. Yeah. The other thing I wanted to mention here is that it's a little interesting that James made a design goal for opvault that you can do a partial UTXO on vault. Especially because he was kind of designing around check template verify. If you have check template verify as part of your kind of withdrawal path, it seems reasonable that you would just encode change back to the vault in that withdrawal path as the CTV. So once the vault is successfully withdrawn from, some change comes back to the vault. You don't really need to do a partial withdrawal. It is very important, or I should say it's at least somewhat important to be able to combine UTXOs in the withdrawal, but I think it's less important to be able to split UTXOs in the withdrawal because of that change via the CTV. Any other questions about restored script vault? Yeah, it did well. That's a great question. So Tidwell asked about fees in this, and it's the same thing. This design of restored script vault is exactly trying to replicate James O'B's opvault. There's probably something better you could do with the stored script around fees. In that, it's always bring your own fee. So one thing about the way these scripts are written is that they look only at a single input or a single output at a time, which means that you're unvaulting, and all of the funds, 100% must go from here to there to prevent any kind of fee theft. That means you have to add fees separately. So you have to have a separate hot wallet that you're going to add an input and an output from to do fees for this, or you need TX sponsors, or you need something else to get fees into this. This design does not cover the fees within the protocol. Yeah, Lolo. Correct. Yep, exactly. So this lets you, like I said, visit your safety key, whatever kind of structure your safety key has, visit it periodically, sign new ways to withdraw from it, and create kind of updated vault withdrawals each time you visit it. Yeah, so that's one of the powerful things about checksig from stack. One of the reasons I like it is that you can do delegations with it. If you have checksig from stack and cat, you can do combined delegations. You can be like, this delegation becomes valid after this time lock, because you can encode the time lock and cat them together and check that. So yeah, delegation is one of the functions you get with checksig from stack that I use here. Yep. Yeah, good observation. Okay. Any other questions on vaults? Otherwise, I have lightning symmetry up next. All right. Yeah. MutinyNet has lenhance on it now. It has CTV, check sig from stack, and internal key. So this vault can be built on MutinyNet right now. It's just Mutiny wallets or Ben the Carman's Signet. You can use it. That's all it is. It's not the new anything. It's just its own thing. At least that's my opinion. Ask Ben. All right. The next thing to talk about before we get fully into Lightning Symmetry is just a little bit about any prev out versus lenhance versus CTV, because it's kind of important input data to how we're going to build Lightning Symmetry here. So here's just kind of a highlight of what's different and the same between check template verify and sig hash any prev out, sig hash all. What's hashed? The green things are the same. The blue and yellow are different. And what you'll notice about what's different is that it kind of doesn't matter in a lot of cases which one of those two things you get signed. So yeah, that's just a quick note there. The one thing that is maybe useful about check template verify relative to any prev out, any script, all here, is that check template verify can constrain future TX IDs, and any prev out cannot. That matters not for LN symmetry, but it matters for some things. So. It still does not constrain TX IDs. There's still malleability in there. So CTV, one of Ruben's like fundamental designs for it was that it could constrain TX IDs, and so he added the sequences, what's that? It's the input side where the TX ID can be malleated because, yeah. So anyway, it just is what it is. Depending on what we're doing in the world of Bitcoin, you could update any prev out to constrain TX IDs. But you do care about them if you're doing something like ARC, because you want to have predictable TX IDs that can be used in a connector for some other use case. They need to be predictable because you're creating an out point. It doesn't work the same. It doesn't work the same. I've tried. Sorry, I'm not repeating what Lalu is saying here. Lalu is saying that because APO signatures are rebindable, you don't need TX IDs to be stable, which is why it was designed that way. However, in the fullness of kind of the intervening 7 years since it was designed, there's been new ideas of connecting by TX ID specifically using an out point, because then you have a consensus rule that ensures there can't be another one that satisfies that. And that's what's important about that. That wasn't kind of in the mind share when APO or no input was being designed. So there's reasons that these things are the way they are. Restored script. We're going to restore script. And restored script includes TX hash as the sig hash modes, and it's going to be amazing. Okay? APO is not dead. APO is evolved. Yeah. This slide's not important. All right, let's talk about how we can build Lightning Symmetry. What is Lightning Symmetry, and what does it take to build it? So Lightning Symmetry, for those who don't know, is a way to do Lightning channels where instead of, if someone force closes a channel with an old state, instead of being able to penalize them and take all of their funds on the channel, instead you can simply advance the state to a later state. And that advancing process can be done repeatedly until no one has a newer state. And the other property of Lightning Symmetry is that the state is symmetric. In the existing Lightning channels that are deployed today, each party has a different set of revocations, because you have to be able to revoke each previous state to correct a channel state if someone force closes with an old state. With Lightning Symmetry, everyone has the same states going along, and whoever has the latest one can just always update the channel to that state in the event of a force close. What does it take to do that? You need to have rebindable signed commitments for the channel updates, because you don't want to have to go through every single state. You don't even want to have to store every single state. So let's say the channel closed, it had 10 updates on it. I force close it, and I put state 5 on chain, but you have state 10. You shouldn't have to remember states 6, 7, 8, and 9. You should be able to just put state 10 directly on chain. That's why you need rebindable commitments. They have to be able to bind onto any state in that sequence and get to the latest one. And then Greg Sanders, InstaGibbs, actually wrote down a full implementation of lightning symmetry and found that you can save a signing round trip, which is pretty important, especially for rapidly updated channels, if you can ensure that the update transactions communicate enough information to allow the settlement path to be encoded in the updates. The original lightning symmetry no input, sorry, the original lightning symmetry design, which was called L2 at the time, used an extra round of signing here so that it was a signed update to the settlement, or signed settlement. We can avoid the signed settlement, avoid that round trip, if we can communicate the settlement data somehow to allow that state to be updated. The details of that will become more clear in the scripts. So the numbers here are not important. I mostly put them there to show that to show my work on the numbers I'm going to show later comparing these. Okay, so we have 5 1/4 kinds of lightning symmetry. First one, the original way that Greg Sanders did it, you use just check sig operators. Stuff we know already, you're just using a different key length. So that's why I put the 0, 1 key and G there, because we're using 33-byte keys that are the TapScript key version 1. And there's a weird thing in here for those who are familiar with how taproot witnesses look, and that is that we have an annex. So in Greg's design for lightning symmetry, he used the annex to communicate that settlement hash and avoid a round trip of signing. But this is cool. And here's the sizes. Here's the red on the bottom there is the total witness size. And the green is the total V bytes to do a unchallenged force close and a challenged force close. I'm guessing I missed a byte or two here or there, but I think I got it very close. All right, so that's any prov out image. That's the original. Those scripts look really nice. Here's if you do any prov out and CTV. Those scripts are even nicer. We just have a settlement hash and a CTV. We don't have that weird, we get rid of that 0, 1 concatenated with the G, the generator point there. We just have settlement hash because we no longer have to kind of do the any prov out signature to get CTV-like behavior. We just have CTV. So that's cool. The sizes get a little bit smaller. What happens if you try to do it with lightning, with lenhance? Just lenhance. Just lenhance is kind of bad. It works, but it's kind of bad. We've got to do 2 signatures because we need to get that settlement hash still on the chain somehow. That settlement hash is needed in order for someone later to bind to that and spend it. They have to know what the contents of the script were. And without that settlement hash, they can't generate the script to know what to sign in order to update it. Okay, so we have to do 2 signatures. This gets big. But the thing I want to note when we look at the fact that this gets big, all right, so it's 330 and 612 witness bytes there versus 238, 414. That's a huge difference. But the V bytes, they're not that different. 731 to 781, it's 50 V bytes. It's kind of a lot, but it's not even 10%. So this is bad, but it's not that bad. What if we had lenhance and cat? Well, that's better. Instead of having the 2 signatures, we just concatenate the 2 pieces of data we needed signatures on, and then check a signature on them. There's one really important thing about doing lenhance cat symmetry here, and that is that you have to either check the length of or hash, one of the 2 things you're going to concatenate together before you check a signature on them. Because otherwise, a malicious user could move bytes between them and make CTV check nothing. Because CTV is a NOP if its input is any length other than 32. But that's fortunately easy. You throw a SHA-256 in there, or a length check. That's why I use the SHA-256 because it's a smaller script, and we get this. This is very comparable to APO symmetry. I forget the exact, there's a table at the end. And then we have restored script symmetry, which I really like. Restored script symmetry, because we can use TX hash, and we know TX hash will give us a 32-byte output. We're not using CTV to check a hash. We get a 32-byte hash, and then we check a signature against that hash that we get with TX hash. We can just cat with the settlement hash. It's safe. No matter what length of settlement hash they give us, if it's not what we chose to sign, they can't move bytes around and have a valid signature. So restored script symmetry looks like this. And it's, yeah, it just works. So settlement hash comes in on, yeah, down here. It comes in from the witness there, which is the same basically as L-enhanced symmetry. It comes in on the witness there as well. Signature, settlement hash, signature update hash. Exactly. Exactly. So Lalu asked, is the settlement hash there to allow clients to be stateless and not remember any state from each update? And that's exactly what it is. In order to keep the data storage on each channel partner of one, each partner needs to be able to update from any state to the final state that they have. And they'd have to store that settlement hash for each state unless it's communicated by the transaction putting an update on the chain. And say again? Yeah, it's the settlement transaction. So the settlement transaction, sorry, Lalu asked what the preimage for the settlement hash is. It is the settlement transaction itself. So settlement transaction outputs are what matters here, right? Because we're defining how we split the channel balance between the two parties. And so the settlement hash is the CTV hash concerning the outputs for that settlement transaction. And because we're trying to avoid this extra signing round trip to, where you could make a a fixed script except for the CLTV changing at each update if you didn't put the settlement hash in the update script. But in order to avoid a signing round trip, we need the settlement hash somehow in the signing script, in the update script. And once the settlement hash is in the update script, we need to have a way to communicate that settlement hash on chain so that it can be updated later. And this is, I'm guessing not everyone has picked that up because it took me several conversations with Greg to understand what the heck he was doing with the settlement hash as well. But eventually I got it. So ask me later and we'll sit down and talk about it if you want to. All right. The last thing I wanted to say is, and I said this in the panel yesterday as well, everyone says cat can do anything, and this isn't something that I have been pushing back on for like 6 straight months now. Cat cannot do anything. It can't do lightning symmetry. But I kind of wonder if it can kind of do something almost like lightning symmetry. I'm trying to get Rindal to try and build this so that we see what it looked like. So if anyone wants to like poke at him, be like, go, build cat-ish symmetry. Because you can't do rebindable signatures with just cat, right? That's just not something it does. We don't have a way in Bitcoin right now to do rebindable signatures. They all bind to at least one UTXO. And so that's it, that's what they do. But because they all bind to at least one UTXO, I think using just cat, you can use 2 signatures that do bind to a UTXO, have your channel start with 2 channel outputs, and that gives, there's like one of those kind of dummy output that allows a later party to do 1 update. So it's not true symmetry where we can update many times. So it wouldn't work for multi-party channels, but for a 2-party channel, you only need 1 update at most. You get the 1 liar and then the 1 update, or the 1 bad backup and the 1 update. So I think you can do cat symmetry with 2 bound signatures using 2 UTXOs. But of course, we don't want lightning with 2 UTXOs per channel. Yes, Arik. Arik's asking, why can't we use the cat trick, where you use the witness stack to constrain certain parts of the transaction, and then fill in just the parts we need to constrain in our cat script to create something like lightning symmetry. And the problem is that we still need to have some signature to authorize each of those cat scripts to be on this channel. And that signature is going to bind to a specific UTXO, so then we can't update it to another one later because we don't know what that UTXO is going to be at the time that first update is made. So we can absolutely have an updatable channel that uses signed updates based on exactly what you described, Arik, to get 2 a state that's a correct state for both parties on the channel. But what we can't do is then correct that without a separate UTXO that inputs to the correction. Right, that's what no input is. Yeah, so cat needs rebindable signature, or sorry, LNHand, or I can't talk now. Lightning symmetry, thank you, needs rebindable signatures. And so you need no input, or you need CTV with chuck sig from stack, or you need some just other new sig hash, like the TX hash as sig hash. You need some way in Bitcoin to have a signature that can be rebound between two different UTXOs. And as soon as you have that, you can build lightning symmetry. And that's part of the point, by the way, of why I showed you all of these ways to build lightning symmetry, is like now that I've dug in with Greg and talked about it for a long time, it turns out it's really easy to get lightning symmetry. We need one little tiny thing. We need to be able to make a rebindable signature, and we can get that from anywhere. It just needs to be rebindable. Okay. That is about lightning symmetry. Here's the comparison I mentioned I would have at the end here. And what's salient about this is not so much the specific numbers, and there's a reason I didn't like color code them in any way. It's really that we can get lightning symmetry in all of these ways, and the numbers are basically the same. Even the worst one, LNHance here, it's just a little bigger. This is for force closes. Force closes are expensive. They've always been expensive. They're always going to be expensive. And the difference is here, it's a 10% range. Not even quite a 10% range. So whatever way we get lightning symmetry, we should really get lightning symmetry. Please? So. Yeah, so I'm glad that we have agreement that we should get lightning symmetry at some point, please. All right, last part of my talk here, and I think it's like a very short break since I'm going over time as well, is OpVault fun. And the reason this part is in this talk, and the reason it's quirky covenants, is that even when you try to design a very specific purpose thing in Bitcoin script, it can be used in lots of different ways. And I wanted to emphasize that. Someone was joking about how everything enables hash rate escrows, and I was like, I wonder if OpVault can do hash rate escrows. Well, here's how OpVault works in a very short thing. I should have put that earlier. Like I said, I rearranged the talk. Here is how you make hash rate escrows with OpVault. It's not even that hard. Because OpVault takes arguments from the stack, and one of the things it takes off the stack is the script that's going to be then used with the arguments. So you can make the script an argument to the script, and then you just propagate the script as long as you want, and now you can make counters because you keep using the same script over and over with new calls to vault. So that's what this does. So you can see the quotes on there that put this whole thing as just a string onto the stack, a byte string, and you copy that along with your OpVault. Is it kind of a big script? Yes. Does it do hash rate escrows? Yes. Yeah, that's really all I wanted to say about that. There's comments on it if you're curious about how exactly it works. And hopefully the link to the slides will be up here somewhere on a website somewhere. If not, you can ask me for them. So yeah, I kind of mentioned part of why this matters. I have a speculation that there is a perfect correlation between anything that we can possibly do that will make true vaults, where you can have an output script you make, which must be spent with a time delay before it goes to its final destination, like that vault feature, that fundamental vault feature. I think anything that can do that must also be able to do hash rate escrows. So if vault is a feature that we want on Bitcoin, we must also build hash rate escrows. I think that's fine. I don't think any problem with that. Yeah, and I mentioned check contract verify here, although I don't think I want to talk about it right this particular moment. All right, any questions? Ryan. No. Okay. So when I got on the plane to come, so the question is, what do I think the best proposal is to get lightning symmetry, basically, right? Yeah. When I got on the plane to come here, it would have been lenhance. Lenhance is my proposal, which has checksum from stack, CTV, and internal key. After talking to Rusty, it's restored script. I want to restore the script. So I like both of those things. I think they're either one is fine. I think Rusty makes a really compelling argument that we're basically going about this the wrong way and trying to upgrade Bitcoin by doing the smallest thing that gets us the features that we want. Like, I really want lightning symmetry. I really want something like arc or timeout trees. I really want some things, and I'm like, okay, here's like the simplest proposal I can do to get those things, and that's what everyone's been doing, right? That's why we have TX hash and we have cat, we have lenhance, and the right thing that we should be doing, and the argument Rusty makes very compellingly, is we should be engineering the best Bitcoin script, not trying to do the smallest thing that gets us the feature specifically that we want. And so that's why I've shifted, after talking to Rusty, from what I got on the plane here as my opinion. So, Lalu. Yeah. So Lola's asking, what exactly is a hash rate escrow? How am I defining that for this purpose? A hash rate escrow, for my purposes, is something that can count down, as Paul Storks likes to say. It just counts down from a big number, and when it gets to 0, it releases something. And the reason you want to do that is you can have a thing that can only happen once per block, and if you don't have a lock on it to who advances it, then the person is going to get to decide how it advances, up or down. That's why there's this yellow line on this slide. You have to be able to go up or down on the counter. And if there's no signature lock on this, the miners are who gets to decide what direction it goes. So it's a hash rate escrow. Whoever wins each block gets to decide which direction the counter goes. And at the end, if it never goes to 0, then you never get the funds. But if it eventually gets to 0, you get the money out. That's a hash rate escrow. That's the destination at the end if it gets to 0. Yeah. So hash rate escrows would protect withdrawals. Yeah. Rob. Oh, God. Yes, please. He makes a valid point. Sorry, Rob was relaying from a Twitter DM chat that apparently there's an error in my lenhance, plain lenhance symmetry, because one of the signatures could be reused between updates, and therefore your channel partner could force close and lie to you, and then you couldn't spend the thing. So there's an error in my slides. You can't do lenhance symmetry the way I had it there. You have to use an opportune instead. It costs like 4 more V-bytes. Chris, you had a question? Okay. All right. Let's call it a wrap then. Thanks, everyone.
Hello, hello. Okay, we're going to go ahead and start this next session.
I don't see anything. Is it on?
Yeah, I'm going to switch it for you, but I'll switch it where it comes up. Just put this behind your ear. Straight back behind your ear. Put this in the pocket.
Behind? Oh yeah, I can see it. Which one? It's a Wayland. It's a Wayland compositor or something like that. I need to know. I cannot read the top bar. Can you like adjust that a little bit? Or can you see the screen? Or can you tell me like? Okay. That's bad. I'll just do something else. Oops. What's going on now? We'll try it like that. Just my setup is broken as always. Am I good to go? Let's get me adjusted. Okay. All right. So thanks for waiting. The schedule is a little bit messed up, but now I'll talk about simplicity, Symphony, and the web. Let's get started. My setup is a little bit messed up too. So first I want to introduce you to what we're trying to solve. With simplicity, we're trying to solve Bitcoin smart contracts. That's the general goal. So simplicity is a kind of programming language that is supposed to be better and solve problems that Bitcoin script has and problems that the EVM has. And the way we do this is simplicity consists of a very small set of operations. We call them combinators. And with those combinators, we do everything. we do everything we want to do. Let's see. It's so small that it fits on a T-shirt, which is here. That's the T-shirt. You can get them outside. I mean, this is only like XL, so not my size, but I implemented simplicity many times, too many times in different ways, and I can attest that it is so simple, it only has 9 commands, give or take, that it is very easy to implement. This means we have like some sort of risk-like runtime. We only have like a very small runtime, very few lines of code for what it does, which means the runtime is very predictable. It has few lines of code, which means we can look at those lines and see, do those lines implement what I think they should implement? We can even go one step further and say, I can write a specification which says each command, each combinator is supposed to do this if it sees these inputs. So we specify, given these inputs, we expect these outputs. We cover every single case, which is possible because we don't have that many cases. We only have 9 combinators, so we only have a few cases to cover. And then we can write a proof that says, this code is correct. This code, the runtime, the C runtime, satisfies the specification, which is a kind of security on Bitcoin which does not exist. Simplicity is powerful enough for smart contracts, so it's more powerful than Bitcoin script is today. But at the same time, it does not have infinite loops, and it's weak enough to analyze. So if the scripting system is too complex, if it enables infinite loops and so on, it's impossible, it's intractable to, it's impossible to track all the different cases. And in general, it's impossible to analyze, to, for instance, bound how much memory can my program use, how much time it will run, and so on. With simplicity, we can do these kinds of things. There's one problem with simplicity, though, which is it looks a bit like an alien language. So as an example, the majority function, so we have 3 bits, and we want to see if the majority is true or false. So for instance, if we have 001, then the majority of bits are false, so we say the majority is false. And if we have 011, then the majority is 1, so we output 1. And this is how we write the program. Cont, true, ident, false. And cont is actually a macro for 3 combinators. It's for case, drop, and true is left injection unit, and false is right injection unit, and false is left injection unit. And it's kind of, yeah, that's, what is that? That's kind of, it's kind of cool, but no one wants to write this kind of stuff. This is confusing. This is where most people, like you read maybe the tech report, the white paper, stop, and they think this is too complicated for them, so they will no longer be interested in simplicity. Simplicity is like functional assembly. So this means we have no variable names, we have no mutability, we have no data structure, so we cannot define a class or some sort of bigger blob of data and do something on this bigger blob. We have to always work on sums and units and products. You can think of it as working on like single bits instead of like bytes or like hashes and whatnot. There are no real functions, so a simplicity program is a function, but you cannot like define f of x and then call f of x with different arguments. It's impossible. So it's like not very nice to define functions and use them in simplicity. And there are also no loops. I mean, first of all, there are no infinite loops, because this would make the language intractable. It would make analysis impossible. We don't want that. We can have bounded loops, but writing these loops, there are different trade-offs, there are different ways to do this, different caveats, and this is definitely non-trivial to do. So normal programmers would not be able to write loops, I claim. Yeah, just repeat this like 1,000 times or like that kind of stuff, right? Like you can repeat the same thing 1,000 times, but maybe you want to write it in a more compact way or in a way that enables compression. So there is this way in simplicity where if you repeat the same thing multiple times, you can collapse it into like one thing. If you repeat one thing 1,000 times f, you only have f once in the program, but you have to be clever how you write the program, so it's actually compressible. So this is one of the caveats I talked about, and these are things that if you just write simplicity off the cuff, you don't know about this, and suddenly you pay like 1,000x more fees, and you're like, okay, what's going on here? So let's not write assembly, let's do something else. And this is where we go to a compiled language, which is called Symphony with an F. So Symphony is a high-level language for humans, a high-level language which Bitcoin developers can write. It looks and feels like Rust, and it's compiled to simplicity. So like Rust, you take Rust, you write Rust, and you compile it to assembly. Rust is written by Rust developers, and assembly is executed by computers. Symphony is written by Bitcoin developers, and simplicity is executed by Bitcoin full nodes. That's the idea. What does it look like? It looks like this, for instance. Do I have a laser pointer or something like that? I don't have to have one. I can point with my finger. Oh, that's like technology. Yeah, I mean, you can see you have let statements. You can have like scopes and stuff. You define some unsigned integers, which awesome. You can have like unsigned integers, which are not like natively supported by simplicity. You do some equality checks. You can compute some arithmetic. So you take a maximum of 2 integers and check if the maximum is equal to something else. This compiles in the Rust compiler. This is valid Rust. You can have functions, so you can define like a 32-bit integer addition, and in a way that it takes 2 32-bit integers and it returns a 32-bit integer, and it panics if there's an overflow, because maybe that's an API that is more useful for you. And then you can call this function and check that the output is the expected output. You can have match statements. So you can give it some value and then match over the different cases and say, okay, if I see this kind of value, I execute this code. If I see this kind of value, I execute this code. Or here, if I see a true bit, I output a 1. If I see a false bit, I output a 0. And then you can do whatever you want to do with it. So this is also valid Rust. This compiles in the Rust compiler. And in general, what I found out is that Rust is really compatible with simplicity. It's like Rust is a mainstream language, and it has these functional features like the pattern matching and the match statements that are exactly like simplicity, but they just look different. And we can use this to make simplicity much more approachable. And you also have loops. So here, again, you have this 32-bit integer addition, and you have some sort of list of integers, and then you can sum them and check that the sum equals to some amount. And the list is also, these lists are arbitrary length up to a certain maximum. So you can work on arbitrarily length lists and stuff like that. So this is Symphony. I encourage you to read more in the documentation that we have. It has a lot of cool features. But I think this is like maybe a show of hands, like, is this more readable than what I showed before? Like, is this more readable? All right. I'm glad to hear that. I think it's also more readable. So Symphony, there's a lot we can do about this. It mainly depends on what you want and how far you let us go, but we want to add data structures. So right now we have like a few unsigned integers, booleans, and so on options, but there are also things like elliptic curve points and elements, assets, and stuff like that that we want to add. And then we want to define a standard lib, for instance, adding a plus or adding adding integer arithmetic and adding equality and stuff. Methods that work on these data structures and on these types. We also want to optimize the simplicity that is generated. Right now the compiler is not very efficient. We want to add debugging features, so basically if you develop Symphony, you can forget about simplicity. Like if you debug, you shouldn't need to look at the assembly code. Like in Rust, we try to emulate the Rust experience, so if you debug Rust, you almost never look at the assembly. You always have some sort of stack trace, and you can look at a Rust expression that failed, and you can stay in the Rust framework, and we try to let people stay in the simplicity framework. Symphony, sorry. And yeah, Symphony, we will integrate it into more tools, so we have like a wallet for simplicity, and we also have something that I will talk about next. So we want Symphony to work with the existing tools. Symphony, if you can compile it to simplicity, but maybe you can also import it directly. You can import directly Symphony code, share it with your friends, edit. It's much more readable than simplicity. And then we did a thing. We thought, why not put it on the web? We have a Symphony IDE, so I spent some time making sure that simplicity runs on WASM, compiles on WASM, and then I built a website where you can run programs, and you can like write programs, get some syntax, get like some parsing errors and stuff, get some feedback while writing the program, and then you can run it and see what happens. So you can select an example program. Like we have some, like the empty program is like a valid string, valid program, and we have some examples of the different syntactic features that simplicity offers. And then we have some, I guess this is like the old version, some examples how you can use Symphony for actual Bitcoin use cases. So maybe a Schnorr verification or like opcat and stuff. And this is a workshop kind of, so a short presentation, then we can like look into that like live and explore this live if you want. You run the program, so you select the program, you run the program. There's an analysis, so it tells you how big is your program, how much would it weigh, and so on. Then you can maybe look at the current fees and calculate how much that would cost. Gives you like a maximum memory usage, maximum runtime usage, based on how long a block is supposed to be valid, how much time you're supposed to spend on each weight unit. If we assume like that one block is validated in 2 seconds. And if there's any error, you get a stack trace. So you can play around with examples, and the examples all run. And if you change something, like if you change the signature slightly, then of course the signature is invalid. And then you can check what the runtime tells you and where it failed. The web IDE, I mean, this is all like experimental stuff, so the web IDE will get some syntax highlighting and some more helpful errors. What I'm excited about is like a Merkle tree explorer. So the simplicity program is also like this Merkleized abstract syntax tree, this Merkle tree, and so, but it can be pretty big. So we will add this interactive, like scrollable Merkle tree explorer where you can like go through the program and take a look at what you would put on the blockchain. There will be a debugger, so you can, basically it will be like, we're trying to emulate the Rust experience. So if you can go through the program line by line and take a look at the current state, what are the variables, what are they defined, and is there any deviation from what I expect? Are the variables, is the state exactly as what I expect? And then you can look for errors. And you will also be able to set a transaction. So things like the signature hash depend on the transaction. And right now there's a hard-coded transaction, but in the future you can change it. And so with the web IDE you can create a simplicity program /Symphony and make sure that it runs in your contract setup before you put it on some sort of blockchain that runs simplicity. So what are your next steps? You should try the web IDE. Try the example programs. See if they run for you. Try, play around with them. Make them fail. See what makes them fail. We have some documentation about Symphony if you want to go a little bit deeper. And then provide feedback, because we need feedback. And this is like, I would say, community effort, because this is a lot of work. We are a very small team. We hope you're excited about Symphony. And I would say thank you and try it out. Yes. Does it use the Rust compiler to check the validity of the program? No, like it's written, the compiler is written in Rust, but it's a custom Rust program, right? So we can enforce this specific rules for Symphony. Like, maybe you're confused. Like I said that I implemented simplicity in the Rust compiler at some point and in different ways, but this has nothing to do with this project. I see. Yeah, I see. Actually, there's this one place where we have invalid Rust syntax. I think we will fix it in the future. But there's this one semicolon that is not allowed in Rust, and so it's not it's not valid Rust. Yeah. 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 Yeah, exactly. That's a good summary. Like, the goal is to define like. Okay, awesome. So like, Symphony looks like Rust, but it is not exactly Rust. Right now, you cannot compile it with the Rust compiler. You have to compile Symphony with the Symphony compiler. And the rules for Rust are not the same rules that are for Symphony. There's a question? Okay. Yeah, okay. I think the restoration is definitely aligned. So it also tries to make script more usable. But to get this in, like you would need a soft fork. Like you can try to run on bit VMs, that kind of stuff. But that's a trick, right? That's not running the literal contracts in one transaction. Yeah, like we want to get it on Liquid first and try it out there, because this is a pretty big update. Like Rusty talked about the big script restoration, but we have like the bigger the bigger restoration. So there needs to be discussion, and there needs to be like thorough testing before we even propose it on Bitcoin. Yeah, I think that's fair to say. Yeah, okay. You have a question? What do jets look like? Okay. Yeah, I mean, jets are basically inbuilt functions. So right now, jets always start with the word jet underscore. I think in the future we might like change the syntax a little bit, but here, like here, right? Like this is jet underscore verify, jet underscore equal 32. So those already exist. You can use them immediately. And things like checked adds are functions you define. And those are not jets. That's the difference. Here's a question. Yeah, that's right. Jets are, you have a list of useful functions. You want to compute useful algorithms, and you have some sort of simplicity program that will compute this, but it's kind of large. So you define C code, which does the same thing, and then use that instead. And you have some sort of proof that says the C code does the same thing as the original simplicity code. So the C code needs to be correct. So it needs, for instance, it needs to compute a correct addition, or it needs to compute a correct EC mult. Yeah, we have, well, the jets are written in verifiable C, and then we use coq to verify the verifiable C. So we say if we have these conditions, like if the inputs look okay, the outputs will also look okay. If we supply the addition function with valid inputs, it gives us the valid outputs, which are the added outputs. Awesome. Question? Yeah, like in the current design, you would need a soft fork. So the idea is we have this list of useful jets that we want, and we discuss like which jets do we want in Bitcoin Core in the soft fork. But once we have that, we commit to this list. And if we change it, we can have a new version of simplicity which has like a different list, ideally a longer list, not a shorter one. But adding a jet is a non-trivial thing. There are ideas maybe how we could like have user-defined jets, but this is like highly experimental, and I'm not sure if we will ever have that. That's a question. Mm-hmm. Yeah, it's closer. Yeah. So how does the cost model work in simplicity? So this is closer to what Rusty explained with the var ops limit. So it's not. I mean, in Bitcoin, in the end, you pay for the size, but this is a very crude kind of measure. In simplicity, we have these combinators and we have these jets, and especially some of these jets are really much more expensive. Like an EC, an elliptic curve addition is much more expensive than just an integer addition or something like that. So we are basically running benchmark like Rusty, and we are assigning costs to each jet and to each combinator. We calculate the total cost of the program, and then we make sure to be backwards compatible that the size of the program represents, is like enough to represent this weight. So we need to
cost or weight or both.
So there's only, in the end, we only have the weight, but we must make sure that the weight is like pays for the CPU cost of the program. So you can imagine a program that is very small but very computationally expensive. And in that case, we have to pad. We have to pad like extra bytes. It's like, I think it's still like an open question how exactly we could do this. We could maybe use the annex and say, like ideally we don't just add like 0 bytes. We say we just have a number and it says like this many bytes are like virtual bytes are in here, like phantom bytes, and then you have to pay for all of these bytes. But the idea is that we want to keep these things simple and not introduce like a second measure for the cost. Okay, there was one question here.
The relationship between the chats and like input output, because like you can have library for math and cryptography, but completely different question is like, can you read a transaction, can you read a block header, can you read a whole blockchain, or like what kind of inputs, how do you get inputs?
Okay, so the question is what kind of introspection can we do in simplicity, and is there like blockchain-wide introspection? Can we like look at the genesis block or block 1, block 10, that kind of stuff, right? So one of the design goals of simplicity is to keep the introspection to the transaction. So there is no like arbitrary blockchain introspection. We can look at the spending transaction, and that's basically it. So and the list of jets defines what introspection we allow. So in a hypothetical world where we don't want covenants, we could say, okay, we don't add any introspection jets, and then simplicity cannot do covenants. Or we could say we go like all in, the entire, like everything in the spending transaction can be introspected, which is the more likely scenario, and then we have covenants. But we will never have arbitrary introspection. Like there's definitely a limit, and the idea is that if you run simplicity, you don't need caches, you don't need to cache like new data, new stuff, because suddenly you have all of this introspection, right? But if you run like a pruned node, you should still be able to run the simplicity programs.
In the IDE or not yet?
Okay, that's a good question. So do we have introspection in the IDE? Let's see. We actually have there. Open your phone or laptop. Let's go, because this is supposed to be like, go to this website. I will try. Yeah, like, but look at this resolution, man. It's like, what's going on here? It's like, this is not good resolution. So we can go to opcdv and stuff. This is opcdv in like approximated in Symphony, and here, right, like you have jet version, jet lock time, blah, 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 all of this stuff. So this is all introspection. You have a hard-coded CDV hash, so the expected hash, and then you verify, and you click, and it works.
And this is more about Symphony, not about simplicity, which is, in Symphony, is there something akin to, in C, I can declare code inline, and so I can insert lower language, lower level assembly into it. Is there a way to do that in Symphony where I can do inline simplicity that's not implemented in Symphony?
Not right now, and I haven't seen that a lot in Rust. So if there's a case to be made, yeah, like if there's a case for like ASM macros, like inline simplicity inside Symphony, because you want to optimize something, or there's some feature that is not supported by Symphony. If there's a case for that, we will add it. Right now, it's still too early for that. We can. Yeah. No, I think those will be like questions that we will have to think about once people actually use this, right? It's like. Yeah, so the compiler doesn't give you a lot of guarantees right now. Like in theory, every time you compile, there could be a different program. This is not the case, but you know that's kind of the guarantees you get. So not a lot of guarantees, and to lock a lot of value in a Symphony program would require you to take a look at the assembly and make sure that it implements what you want to implement. For now, we have to keep the scope kind of small because there's like, well, I'm the only guy working on this, so but it's a really cool idea. And you know, if this matures and if people use this more and if there's demand, then I'm sure we will add it. Okay, that's a question.
How is it so fast?
How is it? Yeah, I mean, like the thing is, why is it so slow? I would say because like here, for instance, you have like the worst example, the firecracker, which crashes your browser, or it doesn't, but it's supposed to run in like 4 microseconds, or milli or whatever, milliseconds, but it takes like 1 second in the browser. Simplicity is just very cool. It's very fast. That's the answer. We're still working on like optimizing the WASM and stuff. Like it takes too long to download. You have like this 2 megabyte blob and stuff, and unfortunately WASM needs to load everything at once, and then it's there. Cannot be loaded in stages, but yeah, I invite you to try it out and give us feedback. Like there are ways to crash it. You can find them. Yeah, open GitHub issues or just write me on Telegram, you know, and let's make Symphony the best it can be, I would say. Cool, and thanks again.
All right. So I just put the REPL link in the Telegram, so you guys can click on that. And then when you hit fork, you should start with this whole setup that we've got here. And then I'm going to need you to do 3 shells. So you're going to want 1 big shell on the left and then 2 little shells on the right. Because we're going to have a couple processes that we're doing here. And I just want to get everybody syncing, and I want to get everybody's vault kind of like sort of set up. And then we're running this on MutinyNet, and for the vault actions, every time you try to do a vault action, it does a rescan. And when it rescans, it has to scan the whole chain. And so that can take like 2 to 3 minutes or whatever. And so what we're kind of going to do is when we start doing a vault action, then I'm going to take a sec to talk about what's happening, like answer some questions, talk a little bit about vaults, and then we'll see some updates as they start happening. Okay? So who's following along? Do we have REPLs up with 3 shells? It's in Telegram, so in BTC++. Or you can go to replit.com/@fedi/opvault-mutinynet-demo. So that looks like this. There. I don't know, can you read that? Or okay. And then once we're here, in the bottom right tab, you're just going to run Bitcoin D. And this has an already synced MutinyNet node in it. So when you hit enter, it'll just start. And then you'll see it syncing for a little bit. There we go. All right, so in the bottom right, you should have a Bitcoin node running around. Okay, good. Yeah, so in the bottom right there, you should do your shell. Shell, okay. Yeah, or you can click next to it where it says shell. Or shell, right there. Yeah, and then do Bitcoin D. So you got 1 shell here, and then you click plus right there. Type shell. There you go. And then up here, plus shell. It's all good. Cool. And then that one, you do Bitcoin D. There you go. Sweet. Oh, click stop on your console. And now do Bitcoin D again. There you go. Sweet. Cool. Okay. We have Bitcoin D. Nice. Okay, you do fork and run. Yep. I got some people doing stuff. Yeah, so fork and run. And you're signing up. And you can follow on your phone too, if you want. Are you in for? Okay, cool. Yeah, so once you get here, then yeah, you can just click X for that one. Then click stop on the top. Then do on the bottom right, see where it says shell. So you're going to do Bitcoin D. Cool. So now you're syncing. Yep. So Bitcoin D. Enter. There you go. Perfect. And then you got your node syncing. Sweet. Okay. Cool. So everyone should be like that. And it should start with it basically synced. But the current MutinyNet block height is 1,143,579. Right. So it'll work your way up there. Okay. So now, the next thing we're going to do is we're going to do a fees wallet, right? So with vaults, what's cool about using OpVault and the covenant system that it uses is that the kind of the whole vaulting structure is sort of like independent, and then when you want to move your vaulted coins, you attach the fees to it, right? So we're going to make a separate wallet that we're going to do that with, right? So for that, we're going to do on the top right, Bitcoin-CLI. Create wallet, and call it fees. Right? So then once we have the fees wallet, then we're going to go over here. We're going to run Python main.py. And that's going to ask us to create a config. And so for that, we're going to do Python create config.py. And that will create our config for our vault, right? And so that's going to make two files. One of them is config.json, and the other one is secrets.json, right? And we'll go over that for a second. So, and once that's created, you'll see a config.json, right? And so this is like some kind of vaulty stuff that we'll go over in a second. So this is like a spend delay of 100. So if I want to move out of the vault, then I have to wait 100 confirmations to like do the end move. It's got like what the recovery pub key is, the recovery auth pub key, the trigger xpub, right? And so the trigger xpub is one that you would put, just like the xpub, you would put into like, I don't know, Blue Wallet or whatever on your phone where you want to like monitor whether or not things are moving out of your vault, for example. It's got some network stuff. And then if we go to secrets, all it has is the private key associated with your vault and then the recovery auth phrase, right? And so what we're going to do is if we want to move from the staging area to the recovery path, we're going to call recover, and then we're going to put our password in, right? And what that'll do is it'll basically take your coins out of danger because they've just been stolen and they're sitting in the recovery trigger path for 100 blocks. While they're in there, the only place they can move is into this recovery path, right? And so we're going to do that in a little bit. But so now back in the shell, over here, once we have the config, we're going to call Python main.py. And this is one of those commands where it's going to be doing a rescan of the whole blockchain. And so it's promised it's running. You're going to see something pop up in a second when it does that. Okay? Cool. So we've talked a lot about covenants this whole time. Who knows what a vault is? Okay, a lot of people put their hands up. Jesse, what is a vault?
From the vault, there's like a time delay.
Yes.
There's a predetermined destination where they're going to go,
Mm-hmm.
and there's an opportunity to, before the time delay elapses, to sweep the coins back to the vault or put them somewhere else.
Yes, exactly, right?
So it's a covenant described in script. It's a very specific kind of covenant, and it's something that gives us a type of security that we don't have in Bitcoin currently. What is the type of security that a vault gives you that you do not have in normal Bitcoin today? So OpVault does let you set amounts, right? So that was one of the differences between OpVault and some of the vault options that Reardon Code went over, right? So normally with Bitcoin you have proactive security, which is that I'm going to set up like a giant moat and a castle and like put alligators in the moat and like all this kind of stuff. And in the middle of this castle is going to be my private key, right? And all of the security that I have around that is stopping people from getting to the key. But once they get the key, they have my coins and there's nothing I can do about it, right? So I open up my phone that has an XPub on it or whatever for monitoring my cold storage or something like that. And one of these days, or like, you know, most people like we shouldn't do that or whatever. They'll like go check their hardware wallets or they'll check their seed plate or something, right? Like once or twice a month or once or twice a year or something like that. And imagine you do that and you try to sign in and you try like put in a Sparrow or something like that, right? And you notice that your coins are gone, right? In Bitcoin today, is there anything that you can do if you notice that that happened? No, because all of the security is proactive, right? Which is all of the security assumptions are based on stop people from getting to this to the key that I've set up, right? Okay, so the thing the vault gives you is reactive security, right? So somebody takes my key and they initiate the transaction in order to try to steal my funds. The vault delay, the spend delay when your config file gives you 100 blocks where the funds are not actually in the place where the attacker is sending them, right? They're in a staging area. And the staging area is like the people broke into my castle, they took my private key, they initiated the transaction or whatever. I can go to my other castle where I have my other recovery key that they didn't break into, and then I can have it sent over there, right? So the attacker doesn't actually get my funds, right? And this is an extremely valuable type of security for certain types of use cases, right? It's probably not the most important for everything, right? But one of them is cold storage, right? So currently with cold storage, there is no reactive security, and in the event that you got hacked, you might not know about it until you next check your cold storage or whatever, right? One of the cool things about reactive security is you can set up really lightweight watchtowers, and those watchtowers can say, hey, we saw a transaction move out of your vault, right? You can do blinded watchtowers, all these kinds of stuff, right? So they don't necessarily know that it's associated with you. And then if the thing moves out of your vault, then you can say, oh, hey, that was me or that wasn't me. And if it wasn't me, then I can go do my whole thing where I do the recovery, right? What's cool about this is the potential of basically making like the big exchange hacks or the big people losing their money that was in their cold storage, which they had some like weird autistic setup for or whatever, right? Basically makes the idea of like that happening just go away, right? Because every time it happens, they have something that they can do reactively, right? So someone tried to steal my coins. It's stuck there for like 2 days, 7 days, 8 days or whatever, right? And during that period, all I have to do is just use my recovery auth phrase to initiate the recovery path. And now they're in like a multi-sig, which I generated in a separate process than what I did to generate these keys. So these keys, when they were compromised, doesn't compromise the recovery auth keys, right? So think about it that way. Like the way that James O'Byrne likes to summarize it is OpVault gives you single sig operational complexity with multi-sig security, right? So normally what you're doing is you just do like a single sig for like authorizations of moving the funds where you put it into the staging area, which then goes on to the follow-on destination after 100 blocks. But in the event that something happens, that immediately gets swept into the multi-sig, right? And so now, in order to do like actually steal your funds, they would have to go compromise that separated multi-sig, which is not the same as what you normally use, right? Okay, does that make sense to everybody? Okay, cool. So let's go look at this. So now if we go over, why is it doing that? Because I don't have Bitcoin D running. Yeah, sometimes it disconnects, and if it disconnects, then just rerun the command. I posted in the Telegram. Okay, cool. So now if you guys look at your vault, the thing that'll say this is the watchtower associated with your vault, right? And it's going to spit out a couple pieces of information for it. So one of them is the fee wallet address, and the other one is the deposit address, okay? So what we're going to do is we're going to deposit into our vault. So copy that address. Yeah, if you're just waiting, then sometimes it takes a sec as it's doing it, right? Like again, it has to scan the whole chain, and MutinyNet's a lot bigger. Like the tool I'm using for this was designed for reg test, right? And so normally reg test, the blockchains are a lot smaller, right? So here I'm gonna deposit 100,000 sats. And eventually it's gonna pick it up. Yep, there's a question. Oh, yeah, you run Bitcoin D on the bottom right pane. You run Bitcoin CLI create wallet fees on the top pane. And then you do Python main.py on the left side. Right, and then so I'm also going to need some money to go into my fees. So I'll take a couple here. Let's do like 10K sats each. That one. This guy. It's kind of annoying. It has to scan the whole blockchain for it. That's okay. Cool. Awesome. So see here, it says saw new deposit of 100,000 sats, right? So that's my watchtower informing me, hey, like you just had a deposit into your vault, right? And now it gave me a new deposit address. I'll put some more into there. Go here. And this is faucet.mutinynet.com. So you guys can just get a bunch of free coins from here. And Ben Carmen has 18 million Bitcoin on this, so feel free to take as much as you want. Right? Let's do another there. There we go. Got another deposit here. And then I'll actually send a little bit more in fees. Start over. Cool. Okay, so I've kind of got everything set up here that I'm going to need. So let's talk a little bit about OpVault specifically. So OpVault is kind of in the same vein of APO and CTV, where this was sort of like a brainchild of, we want covenants on Bitcoin, but people don't seem to want generalized covenants. So let's try to limit this down to like the tightest specific type of covenant for this thing that we can do and try to prove that it doesn't do all of these other generalized covenants. There's a couple issues with this. So one of them is that OpVault works really, really, really well with CTV, right? And so kind of doing OpVault without CTV has like a bunch of really negative side effects. And so you don't want to do OpVault without CTV. With OpVault and CTV, you can kind of do a Reindahl sort of opcat trick, but with these, but this time with OpVault and CTV, in order to have a more generalized covenant, right? And so this is like another thing that we've kind of figured out in the last year and a half or so, that it's very, very hard to do these limited type covenants without opening up generalized covenants. One of the cases to make specifically for OpVault is that the general most popular thing that is happening with Bitcoin right now is store of value. And there are certain circumstances for store of value for Bitcoin where using vaults are a strict improvement, right? And so that's the case to make for it. But you can get the effects of OpVault just like with L-Enhance. If you have CAT, you can like simulate it in a couple different ways. If you have OpTX, right, like that, OpTX is 0 implementation is CTV, so you like get the same functionality with this, right? And so, generally speaking, OpVault is kind of the simplest, most straightforward way, specifically of doing this vaulting type of covenant, right? And that's like kind of the case for why you'd want it. Okay, cool. So now what we're going to do is we're going to initiate a withdraw, right? And so when we do this withdraw, it's going to go into the staging area. The staging area is going to be stuck there for about 100 blocks, and then it's going to have a CTV associated with it, which will send it to the follow-on location at the end of it, right? So for this one, I'm just going to try to send it back to the faucet. So I get an address here, and then I run Python main.py withdraw that. Oh, I need sats. Sorry. Let's do 30,000 sats. 30,000. Cool. And then this is doing another rescan, right? So it like takes a little while. Okay, so is everybody kind of in this same area of that they've got the vault set up and that they're depositing from the faucet onto into their vault? You also need to deposit into the fees, right? Because again, when you're vaulting for these things, one of the issues with the way that you could currently kind of do vaults is using pre-signed transactions. When you pre-sign the transaction, you also have to guess what the fees are going to be, right? One of the cool things about OpVault is that the whole OpVault process is entirely separate from the fees. The fees you attach separately, right? And so because of that, you don't have to guess what the fees are going to be. And so OpVault is, in the event that it's a high fee environment or in the event that you're creating it during a low fee environment or whatever, right? Like that's not going to affect it. It's only going to affect it at the time that you actually do the withdrawal or at the time that you do the recovery path. Okay. Cool. Okay, so we can see here that we just started a withdraw. And I can go look at this guy, right? And we can see here that there's been a submitted trigger transaction for that amount. And we can see that it has 1 confirmation and it has 99 to go, right? So our watchtower is telling us, hey, there was a withdrawal from your vault and this is still in the staging area right now, right? So I could go look on chain and see what that looks like. There we go. Right? Oh wait, no. Sorry, that was the initiation right there. This guy. Yeah, so this is my on vault right here. Right? Cool. So it's still in this staging area. And you can see that the trigger has 2 confirmations, got 98 to go, right? And so this is a withdraw that I did on purpose, right? And so I'm cool with this. I just have to wait this additional period of time in order for it to eventually go where it needs to go, right? But now this is the really cool part of opvault, right? Is that what I'm going to do now is I'm going to get wrench attacked. Is that somebody's going to come along and they're going to decide, because Ben the Carmen heard that I was taking all of his MutinyNet Bitcoin. And so he comes along and he wants it back. And so he's going to compromise my keys, and he's going to initiate a steal transaction. And he's going to try to steal 30,000 sats back, okay? And so this is one where I didn't tell my vault that I did this on purpose, right? And so the vault is going to pick up, the vault watchtower is going to pick up that this transaction happened, and it's going to say, hey, you didn't tell me this was going to happen, so I'm going to tell you that someone might be stealing from you, right? So this is going to take another little sec. Is everybody kind of on the same area? Yeah, you have to restart. That's fine. You just have to keep it restarting. There you go. Oh, you have to send more stuff to your fee. So, it might be just the number of UTXOs, whatever. Withdraw L. That's the wrong. Okay, yeah, so that started it, right? Oh, okay, that might be an issue. You can like kill the config, and then you can like recreate the config, and then just redo the vault. Okay, cool. Okay, so crap, insufficient fees. Oh, I got the same error. That's okay. All right. Yeah. Well, that's okay. Now my vault doesn't seem to be working, and so what I'm going to do is I'm going to freak out, and I'm going to do main.py recover. Right? And so because everything is in the staging area right now, right, the only path that it can go through in order to get out of danger is to go down this recovery path, right? And I can still do this because it's in the staging area, right? And we'll look at the transaction for it being in the staging area. That's the same amount, 3424, 3424. So everybody kind of have their wallets sort of set up, sort of working? Oh no, it's still running. It's just that it has, yeah, it has to run rescan every time it does it, because it's a this is normally a reg test tool. But it has to rescan the whole thing. So the withdraw, you'll see it pop up. Okay, cool. You have something? Or, kind of running. Yep. Okay. Cool. Yeah, like 30,000 or something. Or you can do steal 30,000. It does the same thing, but one of them sends a notification, one of them doesn't. Cool. Yeah, you can just run main.py instead of monitor. It'll do that. Cool. Is your Bitcoin node running for this? Yeah. Okay. Okay. Cool. Okay. So if you look on mine, so see how it says, hey, recovering all these sats, right? So these are the outputs that are in the staging area that I'm going to recover by doing this. And so what I'm going to do is go look in my secrets.json and use my recovery phrase. There we go. Sweet. So I just initiated the recovery transaction. So let's go look this up. Cool. So that's my recovery transaction. Okay, so we can go look at this. We'll go through this in a little bit later, like actually looking through the witness of what went down here. But yeah, that's my recovery transaction. So you should see over here in a second, vaults recovered, right? And this goes through my coins that were in the staging area that I then did the recovery for, and now it pushed it into the recovery wallet, right? So now this recovery wallet that I have, that could be like a 3 of 4. It could be like something where I've set up with like lawyers and other custodians and all that kind of thing or whatever, right? It's like an opportunity for, this is the one where now that it's safe, I have time and I can go around and I can say, hey, this is my like 6-week plan where I go to the 12 different countries where I've stored all my different key shards or whatever and then put it all back together. But the important part is that I got a notification when my coins were getting stolen from me. There was something I could do about it, which is the big change, right? Is that today, once you get hacked, there is nothing you can do, right? And so in the event that that happens, I can immediately put myself into a position where in order for the person to actually successfully steal from me, right, they would have to compromise this giant crazy thing that I've set up for the recovery. But on a day-to-day of just using my like normal single sig, right, I'm totally fine as long as I'm okay with this spend delay, right? And you can think about how, like with more generalized covenants, how you could do much more complex schemes than this, right? Like you could have like multiple different recovery paths. You could have like recovery paths that fail over after certain amounts of time and all that kind of stuff, right? But just the generalized principle of this that I really think is important for this is that currently within Bitcoin, there is no reactive security, right? And the vault is the very simplest way that we can get reactive security such that all of the horror stories that you've heard about, oh, I lost all my Bitcoin, right? That basically stops happening, right? Because people, like, if your key gets compromised, they have a recovery path where they can go to like a much more complex thing that they don't actually have to deal with like all that often, right? It's very valuable to kind of keep this in mind of like a improvement on the most common thing that people do with their Bitcoin today, which is they hold it, right? Okay, that's kind of it. We can go through like the specific scripting or whatever, but like we went through most of that with like written code, but we can ask about that a little bit, but yeah.
If vaults become very common, does this change the how we should think about private keys? Like, is it that bad to have your keys in Google Drive now? If there's always
well, it's too bad.
Seriously,
yeah, it's not nearly as bad. It's like the issue, like there's a couple issues right now in Bitcoin, right? Where like one of them, for example, is that for your Lightning node, is that the moment that your Lightning node pub key is doxed, like you're kind of doxed forever, right? There is no changing your Lightning key, public key, right? The other one is if your key goes hot, right? That is basically compromised forever for any of your cold storage or any of this stuff, right? And normally is that if you want to have like a good setup for your cold storage, you want it to be multi-sig, you want it to be those things. There's a bunch of operational complexity associated with that though, and like, hey, sometimes I want to move my funds out of the way, but like I don't want to have to go do the round trip to like the 12 different people in the 12 different countries or whatever in order to make that move, right? So you as the primary operator of the vault, right? As long as you are okay with the spend delay, and the spend delay can be 100 blocks, it can be 1,000 blocks, it can be 10 blocks or whatever, right? Like, as long as you're okay doing that, then you, on a day-to-day basis, have single-sig operational complexity, right? Which is that I decide that I want to move my funds to this place, right? But you get, in the event that you're compromised or in the event that something happens, you get the security of the multi-sig, right? And so I think wallets generally are going to, like they work really well today with like one or the other, but this is like a good way to have just mostly single sig operational complexity, and then in the event that something bad happens, you sweep it into multi-sig. So for example, one of the ones that I think would be really valuable for this is using this for Fediments, right? Because normally what Fediment does is has a hot, always-on wallet, right? Is that when you're doing withdrawals from the Fediment, is that the keys are basically like always running these consensus rounds for the Fediment, right? So now imagine if the Guardian, who actually has to, instead of have to always be monitoring the node and always have to be checking with the other guardians for all these other things or whatever, what if, hey, we did this, right? We did this withdraw, this sort of thing, and what we can do is the moment that something bad happens, then we put the stuff into the recovery path, the guardians can, at their own time and at their own leisure, figure out what happened. They can like do a recovery for that one, because anything where you actually have to have the keys hot is like, in the event you get hacked, you're just screwed right now. Right?
But I mean, you have to do another transaction to get it out of the trigger.
Yeah. So basically, the fees associated with the fee that you attach to it, right? That gets kind of bumped when you do the replace by fee for it, right? So it's like, hey, this one has a CTV to do to the ultimate withdrawal path over there, right? And you have to get your transaction confirmed while it's still in the staging area, right? But again, this staging area, it can be 100 blocks, it can be 1,000 blocks, it can be like something like that, right? So you do have to get that transaction confirmed, right, after it's been moved out. But what you can do there is you do it and it goes into this recovery path. And like, again, the recovery path, you can make it as complex as you want, right? And you can make it so, like, you know, you've got the different seed plates that you're like buried in the ground in 12 different countries or whatever, right? It's just like currently, if you do that, those coins are not moving at all, right? Like you don't get to, hey, I need some of my funds to move it to this other thing, or I need to put a little bit more in there, right? But like now with this, you actually do get that, right? And so in the event that something actually did happen, you do have the multi-sig security at the very end of it, but you still have the possibility, like if I'm operating a business or whatever, if I'm operating an exchange, right? Like, you know, there's like certain like Bitcoin exchanges where the CEOs are like, hey, I go to sleep like terrified every single day, right? It's like, what if I wake up and something's happened? But with reactive security through vaults, suddenly it's, hey, if something happens, there's something I can do about it, right? Which is like a huge change to the way that this stuff works. Yeah.
What does the criminal see?
What does the criminal see? So you initiate a transaction, right? And you tell your vault that that was me, right? So the criminal, if they compromise your key and they initiate the transaction, right? If you're using a watchtower, then the watchtower notifies you, and you're like, oh, hey, that wasn't me, right? But if you're not using a watchtower, then you do have to like check in on it every once in a while, right? But just generally, like watchtowers become super, super easy to do once you have something like this set up.
What if the criminal tells the watchtower that it was you?
So for that one, you'd have to compromise both your watchtower and the private key. Okay.
In your demo here, you had like a Python withdrawal, right? What if the criminal just did Python withdrawal?
Yeah, so the difference is when I do withdraw versus when I do steal, right? There's two things that are happening. So when I initiate a withdrawal myself, I'm also telling the watchtower, hey, that was me.
Right. How do you authenticate to the watchtower?
Yeah, so I mean, it would depend on like the setup that you want to do, right? But like, you know, you can do it like, hey, I've set it up on my phone, but it's separate from the actual like uses of the private key. You can have them separated on different apps, whatever it is, right? But like, or you could just have it not be that way at all, right? It's just like because the reason why I have the authentication or whatever is so that it doesn't like send me all of those notifications of like you've been stolen from or whatever, right? But you could have it that way. Just the watchtower, it tells me about everything, right? And so even if it's me or even if it's somebody else or whatever, I just get a notification every time something moves, right? So.
And the criminal themselves, do they see that they failed? Do they know they've been thwarted? They just see like.
Well, the only way to move the coins is to put it into that staging area, right? So the criminal sees that, hey, I initiated this transaction, sending to myself, but it's a follow-on transaction after it's been in this place for 100 blocks, right? Okay. So they do the first transaction that puts it in the 100 blocks, right? And so they'll see it waiting there,
right?
If they were to do that.
You just answered the question, which was, in order to use the funds in the vault, you have to wait that time.
Yes.
So 100 seems like a long time to wait when you're trying to make a regular payment.
Yeah.
But 1,000 is even longer. So you should pick that time carefully to be both acceptable for your normal business operations and
exactly
enough time.
If you like going sailing the ocean for a week at a time.
Yeah, right. Well, this is so like I think the most functional thing about this right is just like think about it if like you've actually done like a cold storage setup with a multi-sig that's split across multiple people or whatever. Like how long would it actually take you to go do that multi-sig recovery? And like that's what you set it based off of. Like take that, double it or whatever, right? And so like I know for me, right, like I've done setups or whatever where it's like I would need to talk to 7 different people, right? and so generally those coins never move because I do not want to go talk to these 7 people, right? And when I just want to do a normal transaction, I don't want to have to go tell them about it or whatever, right? It's like just coins that I've just set up and I do not move them under any circumstances, right? But like now what I could do is I could just individually as an operator do that. And for when you're setting up these multi-sigs or whatever, right, is that you're just using multiple keys from these different people, right? So like imagine you're a cosigner on like like 15 different people's vaults, whatever, right? And you're just one of those many co-signers.
Yeah, and in practice, you could also have something more complicated. Like not just have the vault like this, but you could have something like where like you have another set of multi-sig wallets where you can do an emergency.
Like that first that normal spend that you do or whatever. Like you could use Frost or something, right? And so it's like, hey, normally on a day-to-day basis it's the 2 of 3, right? But like in the event that the 2 of 3 is compromised, then it goes into like a 7 of 12 or something. Or, I don't know. Like whatever you want to do. But like the whole idea behind it, right, is that you have separate key generation processes that never touch each other. One of them can be like crazy, like you don't want to, something that you like takes a while to handle, right? But the other one, just for operational simplicity of like, this is funds that I will actually be using and like moving from one thing to another or whatever, doesn't require me break glass in case of emergency or whatever. But I always have that option, right? Yeah.
If your recovery phrase was wrong, what would happen?
The recovery phrase is basically hash into a private key and then used to sign a transaction. So you do need to like maintain the recovery key.
Right? I want a little more entropy than that one.
Yeah, you don't want to. That's why it says change me, right? Yeah. So, but the whole idea behind the password or whatever, right, is this is just like hey, like stop everything, just throw it all in that vault, right? And so what you want to do is it would want to be something where it's like, hey, you get the notification, it's like from your phone, you can just like put the passphrase in, go, now it's suddenly in a safe place, right?
So there's an annoying attack, someone steals the recovery phrase, and then just
Yeah, so let's say that somebody does that or whatever, they say the recovery phrase, and now you do that. But like the important part about it is that they don't have your coins at the very end, right? And like I think of that as just a fundamentally different paradigm than the one that we currently live in, which is that a successful attack today means you no longer have your coins, and there's no recovery mechanism at all, right? And so just imagine what Bitcoin looks like if after 5 years there has never been a serious attack that ended up with someone losing all of their coins, right? And like the case that you can make to institutions, to custodians, like all that kind of stuff. Like even today, right? It's like you look at the ETFs, like Coinbase is like the only custodian. There's like Fidelity, right? Just because there's like a couple of Bitcoiners there. But like the other guys, I don't think the reason why, like they do custody for like all sorts of other stuff, right? But like why not do it for Bitcoin as well? Is like, I think there's serious problems of not having reactive security for this one. Is that the reactive security they have in the dollar or whatever, right? Is that they just go to the Fed makes it right, you get the coins back, or you get the funds back. But for this one, it would be, hey, there is a mistake, there's something like that. This goes into like the craziest multi-sig cross-institutional party with service level agreements that you possibly set up, right? And then now it's like no one ends up actually losing the coins, right? Which is pretty huge.
So I get this being super useful for someone stealing your passphrase, but for a wrench attack, doesn't it make it more dangerous?
In what way?
In the sense that if I try to steal your coins, I only have to wait roughly 10 minutes to figure out that I have control over them, and then I can fuck off.
So you wrench attack me to get my private key?
Yeah, I wait for 10 minutes, verify that I received them, and then I go on my own way.
No, so...
But in this case, right, I have to wait for 100 blocks. Like,
yes.
I try to
100 blocks, and if, for example, like...
Yeah, I mean, the watchtower says...
If the watchtower, like, for example, one of the things you can do with the watchtower is that if I don't send you an authorization for having moved this money or whatever, just auto-send my recovery, right? And so now we'll just sweep everything out of there and then put it into the recovery path. Yeah, so again, it's different sets of trade-offs, right? Of like, hey, well, like you were saying, right? If like, what if somebody gets a recovery phrase or whatever, then they like screw you over or whatever. But like the categorical difference for this is that at the end of this attack, who has the Bitcoin for this? And there's very, very few ways of engaging an attack against someone who's using a vault in some sort of reasonable way that doesn't end up with them having the Bitcoin at the end of the attack, right? Versus today, which is if you are attacked successfully, you do not have your coins. Right?
But if they know that you've got it in the vault, though, doesn't the wrench work still?
Yeah, well, in certain ways or whatever, right? But it's a different type of attack, right? So let's say you like actually wrench attack me or whatever, right? And like for me, just like again, like I've got some pretty complex setups or whatever, right? Like my recovery path would probably take me something on the order of 2,000 blocks, right? So like you wrench attack me, and now at any point during the next 2 weeks, right? Like let's say that hey, I've got like a friend who's concerned about me or whatever. He has my recovery phrase or something, right? Let's say that I have a watchtower. Let's say that I have a lawyer or something like that who has the recovery phrase. And in the event that like I don't have like a proof of life in like 2 weeks or something like that, right? They can just do the recovery path, right? They can initiate that transaction.
Of course, if you've given them all the information to get your complex recovery.
But for them, in this example, for one, it's like, hey, just one of these guys just has the recovery phrase, right? Like
right, but let's say they wrench attack you and kill you, right? Now,
well, I mean, if I'm dead, then my coins are
you might want them to go to somebody else.
Yeah, and you could do that, right? And this is where like the more general covenants and the complex scripting comes in, right? So it's like, hey, you put something in a vault, the vault is only like time locked for like, hey, 1 year, and after 1 year, it just fails over to being directly recoverable by the recovery path or whatever, right? Instead of having to do the staging area. Like all of this is possible, right? But I think again, like categorical difference between at the end of this attack, I lose all my coins versus at the end of this attack, I have a very good chance of still having my coins at the very end of it.
Yeah.
Right?
Also, like a more realistic, the $5 wrench attack is like fun to talk about because it's funny, but like, a much more realistic attack is like you're at a company and then you have a cyber attack and then keys are compromised.
Yeah.
And like then this is completely applicable and it completely protects you.
And this has happened like a bunch of times, right? Is that like if your key gets compromised, all of your coins are gone and there's nothing you can do about it, right? Versus having to compromise many different sets of keys which have never been in the same location that has many different backups associated with these things just out of the box, right?
It's like two-factor authentication.
Yeah, and like the blinded watchtowers associated with this become really, really, really powerful, right? And so, yeah.
Is there a limit on the time delay?
With op vault specifically, or no? I don't think there's any limit, but you set it by block height, right? And so, well, relative. You check the relative block confirmations.
A couple billion blocks.
Yeah, maybe we can do that, right? But
last question, then we gotta.
Yeah, sure.
Go for it.
Any questions?
Yeah. So how do you implement this?
Well, this is based off James's work, right? So I just kind of modified it a little bit to do MutinyNet instead of that one. But this is currently live on MutinyNet, right? So you can do vault transactions for it, right? And the scripts associated with doing this are in the BIP. And the scripts like this, right? There's like trigger op, spend delay, op CSV, op drop, op CTV, op vault, right? And so, yeah, and the code for it is all in the replit, right here, and it's just written in Python, right? So it's like pretty readable. Okay, cool, thanks.
Don't worry about switching it over. We'll do it quick.
Yeah, it's easier if I give you guys slides.
Oh,
my laptop doesn't.
Yeah, you
can use mine.
Have you sent them already?
You will send it to me. Oh, so that works.
Okay.
Alright, where is easy split? Telegram? I second. Signal works. 210.
Oh, maybe signal. Here,
yeah.
Okay.
Oh, right.
Nice, thank you. I'll definitely try to push things along. I'm good at Java. I guess.
You see my port in my laptop.
I guess I'll save you.
It should be PDF. Let me guess, this is, yeah, probably this is the extension. There you go, there we go. Yeah, that's right now. Should be able to do it. Should have done. Alright, does anyone care about seeing expire? Say it again? Yeah. You want to watch it? Alright, I can present to 3 people. And I'm going to do this quick because you all want to go home. So, expire, what is it? Anti-check lock time verify. It does basically the opposite of it, which is, you know, if you remember check lock time verify, it's associated in lock time. You prevent a transaction or an output from basically being spendable until a time period. Expire, as the name suggests, prevents it from being spendable or mineable after a time period. And concretely, that means we actually need 2 things in it to make a usable thing. One is we need a expire opcode, but then we also need some kind of like expire height field. Unfortunately, we have the taproot annex, so this is actually doable in taproot. And being a new thing, it's probably fine to just not allow it in old stuff. And, you know, that's simple enough. Well, why would you use it? Well, there's a whole bunch of stuff, like auction bids, time-limited delegation, provably unspent... Because lock time just doesn't have the bits to do it. And also, sometimes you're going to want to do both. So, like, you know, lock time has a meaning already, and there's no easy way to say, well, lock time, but interpret it differently or something. Like, I did propose maybe you could, like, squeeze into version bits or something, but, you know, just doing it as taproot annex field seems pretty reasonable. Yeah, it's probably all right. And, you know, and I got to point out, too, like, if you somehow have a transaction which doesn't have signatures on this stuff, you can always just change the fields anyway. Yeah. So, like, it has to be in something that's signed. But yeah, you know, auction bids, time of provably unspendable outputs is an interesting one, because, you know, we do have op return right now, but sometimes you might want an output that disappears from the UTXO set after a period of time. Now, actually doing this is a little tricky, because then you got to pick, well, what opcode is it going to be? Like, are you going to do it like repurposing a taproot op success or something? But, you know, it's something that can be debated later. I've been told, although I haven't bothered thinking in much detail how the heck vaults would go use this. I'm sure people who care about vaults can figure that out. And the one that I came up with, the whole reason I came up with opcode at all, or at least proposed it and wrote it up, was the transaction cycling attack. And I think this one's interesting because it kind of, it speaks to something where I think people have been often, maybe, you know, not so much misunderstanding, but just kind of not thinking through the implications, which is, you know, HTLCs, right? They're pre-image or refund after timeout. The problem is that is a programmer's OR. It is not an exclusive OR. And, you know, I could give a 20-minute talk on transaction cycling attack. Actually, no, I couldn't, because I have to remind myself how the hell does it actually work. But, you know, the basic issue with that is the pre-image part of that can happen later than you'd expect. So if you add an op expire to that, well, the pre-image thing can't happen after you wanted it to. Thus, that solves the transaction cycling attack. Because the attacker, their choices are really to either collect the money when they give the other guy the possibility to collect the money too, or not get the money. Solves it quite nicely. So the other question is, well, why haven't we done this before? And, you know, the whole idea of making transactions in any form that become unmineable in the future really comes down to reorg risk. You know, because we have this idea that if a bunch of blocks get reorged in some massive technical failure, we want all the transactions in those blocks to eventually be able to get into the chain. And lock time has this property because we assume that reorgs aren't somehow going to make the chain shorter. They can actually, technically speaking, but that sort of reorg situation is, I think, kind of so, it's sort of like so rare and so unlikely we can ignore it. So, and lock time hasn't had this problem, but expiry definitely does, because you could wind up with some empty blocks and then maybe it's just impossible to get in. Well, what's the solution? Well, you got to ask, well, why is reorg risk a problem? I mean, we don't so much care about the transactions getting screwed up. We care about the transactions after getting screwed up. And we already have this issue with Coinbases, because, you know, if you spend a Coinbase output, it gets reorged out, it's invalid. And Coinbases are unspendable for, I think it's 100 blocks, 101 blocks. There was an off by one error in this somewhere. But, you know, they're unspendable for a while. So you could imagine fixing this reorg risk by making n expiry height using transactions, the outputs of them unspendable for, say, 100 blocks, or maybe 10 blocks is enough. You know, that can be bike shedded over. But I argue, certainly if it's no worse than Coinbase's, it's acceptable. Might not be as useful, but it is acceptable.
Where does op expire come into that? I think I missed that.
Well, because op expire, to make it useful, what you're really saying is that a transaction spending an op expire cannot be mined after a point in time. All right, so like check lock time verify, op expire, the most likely implementation would check an expiry height field, and an expiry height would say the transaction containing this cannot be mined at some point in the future. You know, that's the equivalent of saying, you know, this output is expired, or at least this branch of the output script is expired and cannot be spent that way. And, you know, like I say, I think it's similar logic to check lock time verify there. And the other bit of why haven't we done this before is, well, this makes mempools kind of complex, because now you have this whole class of transactions that could drop out of the mempool forcefully. You know, this is potentially a free relay attack. You know, you can imagine sending out a bunch of transactions with really low fees that are going to expire the next block. And the chance of the transactions actually getting mined is pretty low. So you're really getting the broadcast data for free. You know, and as I've argued in my talk yesterday, well, we already have free relay attacks, but this is a particularly free version of it with very little cost versus, you know, low cost. But there's an easy solution to this, which is you say, well, if transaction's accepted into your mempool with an expiry time, if the expiry time is reasonably close, well, you should go require higher fees. I mean, the obvious way to do is just say it's got to be a fee high enough to probably get mined in the next block. And implementing this is currently kind of hard because you can't ask the question, well, what is a fee high enough to get in the next block due to how we design mempools? But, you know, I'm sure we'll fix that at some point, so it might make op expire easier to implement. And finally, why did I talk about expiry heights? Why not, like, time? Well, because time is weird. And time has all kinds of crazy, weird incentives that are possible because, you know, like a lot of people have this idea that like Bitcoin serves as a clock. That's not really true. The definition of validating a Bitcoin block correctly requires you to have an accurate local clock because the part of the definition is the time field more than 2 hours into the future? Which is also a very bizarre thing to have because, you know, your and my clock are not going to be absolutely identical. And we kind of hand wave over this, and we really hope miners don't exploit this. Well, let's not give them more reasons to play with time. Like, we're all better off if no one looks too hard at this weirdness in Bitcoin, and height is good enough. You know, I can't really, like, any circumstance where you've got an expiry time, the reality is, at least currently, the block adjustment interval works pretty well. It's never off by more than, you know, 10, 20%. Certainly never off by more than like 10x in either way, so it's fine. Just do it by height. Simple as that. And finally, deployment. Well, I would suggest hats. That seems to be the way we deploy things. You might want to do a better job at making the hat than that. I use GIMP, and I typed op expire with the default sans serif font. You know, I hear there's cool things you do with like little rubberized 3D things, but, you know, I'm sure we'll figure out some deployment thing. You know, one argument here is like if op expire is actually useful, Maybe the way we do deployment is by saying, hey, here's an uncontroversial thing. Let's see if we can get an uncontroversial thing in. I don't think that's the case, because op-expire has more than one use case. Like, if all it did was fix lightning HTLCs, I might have a point. Unfortunately, I don't, because it looks like there are other use cases. And I don't, people might oppose it based on, well, maybe you can use it for like ordinal inscription auctions or something. I don't know. But it is what it is. So with that, questions? Uh-oh. Well, I'll ask him. There. You already asked one.
Do you get generalized covenants with op-expire?
God, I hope not. But I'm not going to say no. Maybe if it was in the morning, I'd say no. But, after watching all like you guys talk about generalized covenants, who the fuck knows? But honestly, I'm pretty confident it doesn't do anything more than the sort of stuff I said.
Yeah.
But even then, I mean, like enabling new types of auctions, I'm sure lots of people hate me for it.
How would you, for setting the fee rate, if you were going to say, hey, this op-expire that expires in the next block, would that, you said it was based off your mempool, or would you base it off of the previous last confirmation?
I mean, realistically, it's going to have to be like the, a local mempool. Yeah. And, a nuance of that too is like, this may of course be a package relay situation, where the transaction itself is not enough, but there was a child one, which of course gets to a problem because I did just say Coinbase-like behavior. Yeah. So, there might be like some opt-out thing you have where maybe if it's in the same block you're allowed. I don't know. I mean, it's a tricky whole design decision. But certainly I think in most use cases it's good enough to just create a bunch of transactions with different fee rates and just rely on RBF for that. Like there's no reason why one op-expire couldn't be replaced by another one. I mean, of course, after all, fee rates could go up after it's accepted. Maybe it's just like any other transaction, still not enough to get in quickly. Yeah. So, but yeah, like that's part of the design criteria and design decisions around this. I'll also go point out, with regard to the Coinbase-like thing, there is precedent for op-expire in other blockchains, and my understanding is most of them just said YOLO, like. If reorgs happen, we'll deal with it. And, I'm not sure that that's, like, so unreasonable. Like, we're already leaning towards making reorgs dangerous anyway with things like ephemeral anchors where, like, anyone can pick them up. Yeah. So, and, of course, RBF has the same issue, too. Yeah. Like, RBF is heavily, heavily used. And in any reorg where miners start doing something weird, you could easily be in a situation where the wrong RBF is in. On the other hand, in situations where the reorg's some technical failure, well, there is argument that at least it provides a possibility of getting in, in a sort of cooperative way. So, I don't know. We can bike shed that more.
So, I was kind of really interested in when you said it will disappear from the UTXO set. That's really useful especially for people who are, like, there's been this kind of...
Well, op-expire could be used for, like, ephemeral anchor outputs as an example.
Yeah, sure, yeah. But also just, like, there's been a lot of spam and like, loading of the UTXO set, and it would be kind of neat. I don't know if it would be useful, but, like, it would be neat if you could opt in to having your transaction become unspendable after a while. The data would still be in the chain, but it's not on the UTXO set.
One nuance of this, of course, is that you do have to do it in a way where it's possible to prove that. Yeah. Right? It's got to be visible to the code that can process the UTXO set. An op return is an example. The reason why it's encoded as op return the thing is so that code can just read the script pub key directly and say, oh yeah, that's op return. Yep. So you'd have to have some standard like, well, maybe it's, some number op expire, maybe drop depending on what exactly the meaning is, and then followed by whatever else is. Of course, that conflicts with how we've defined like taproot and stuff like that. Because we say taproot is this fixed script pub key, not this, not an opcode. Like, if we'd done op eval or op taproot, it'd be a different discussion.
Yeah, I guess it would work if you had, like, one branch that was op-expired, but if you had a bunch of branches that were op-expired.
I mean, even one, well, if it's one branch in a very predefined way, but then it's not very useful. Because how do you add some other thing? I mean, maybe if it's only for ephemeral outputs and absolutely nothing else, maybe that's enough. But,
or like I said, if it's to store arbitrary data.
Well, there's that too. But I mean, the problem is, though, if it's to store arbitrary data, well, the data, again, you get into this thing of how exactly did we encode op-expire? Because script pub keys are only version 0 scripting, right? All the taproot scripting is not part of version 0 scripting. So I can't like repurpose an op success for this. It would have to actually be op expire verify. Yeah. Yeah, you can bike shit this stuff to death. But cool. All right, we're done. Let's go home. Let's eat.